texted Joe, and he said that he's on his way to join. He's having some problem getting out of his home.
Okay, thank you, Ahmad.
Sure.
Okay, good morning, everyone. Welcome to the meeting of the Scientific Review Panel. We have several items on today's agenda that we'll talk about in a minute. First, I'd like to welcome everyone to the webcast, and the meeting will be recorded. Arash, I assume you're going to take care of that. We're going to start with panel introductions. So I'm pleased to welcome our newest member, Dr. Pamela Line from UC Davis, who's the pathologist representative on the panel. Unfortunately, she's sick today, so won't be able to join us. I'm also happy to say that I have been reappointed as the atmospheric science representative and chair of the panel. So it's nice to be back. And then finally, Ahmad Besartinia has also been reappointed as the oncologist representative to the panel. So Ahmad, thank you for your continued service. Going to go around and I'll just have each panel member briefly introduce themselves. Beata, do you want to start?
Yes. So I'm Beata Ritz, professor of epidemiology and environmental health from the Fielding School of Public Health at UCLA. And I do a lot of research on air pollution and health outcomes, as well as pesticides and health outcomes in the state of California.
Thank you, Beata. Paul?
I'm Paul Blanc. I'm professor of medicine at the University of California, San Francisco, and chief of the Division of Occupational, Environmental, and Climate Medicine there. And my research focuses on largely on occupational inhalation exposures.
Thank you, Paul. Karen?
Yes, good morning. I'm Karen Messer from UC San Diego. I'm a professor of biostatistics in the Herbert Wertheim School of Public Health. I'm the director of biostatistics at Moore's UCSD Cancer Center. And I have a lot of expertise in causal inference. So in methods of assessing for and correcting for bias that can arise in observational data.
Thank you, Karen. Ahmad, you want to give yourself a fuller introduction than what I did?
Thank you, Kurt. Happy to be reappointed and continue to work on serve on this very important panel. I'm Ahmad Besartinia. I'm a professor at the Department of Population and Public Health Sciences at the University of Southern California here in Los Angeles. I'm a cancer biologist, and my background is in molecular epidemiology, genetic toxicology, and public health.
Thank you, Ahmad. Kathy?
I'm Catherine Hammond from the University of California, Berkeley School of Public Health. I'm a professor emerita. My research is in occupational and environmental health. I've done a lot of work in the Central Valley, especially around Fresno, and air pollution in children's health, and occupationally studied the various effects of the work environment on workers in the light metals industry and automobile manufacturing, automobile repair, semiconductor industry, the railroads, and diesel exhaust, which was my first encounter at the Science Review panel. And I'm happy to be here, and good morning to everybody.
Thank you, Kathy. I didn't realize you had retired. When did that happen?
July 1st, that's on the books, but the people who know me say it's hard to tell.
Well, congratulations.
Thank you.
All right, Joe.
Hi, good morning. I'm Joe Landolf. I work at the University of Southern California. There, I'm a member with tenure of the Department of Molecular Microbiology and Immunology and Department of Pathology. And I'm a member of the USC Norris Comprehensive Cancer Center. My training and work has been in the area of chemical toxicity and chemical carcinogenesis. We've specialized in working on, early in my career, polycyclic hydrocarbons, and now we're working on nickel, arsenic, and chromium. And we've just shown that nickel is mutagenic, contrasting what people would thought. So it's a mixed agent, and it does things by epigenetic mechanisms, as Max Costa has shown, and also by genotoxic mechanisms, as we have shown and continue to work on. And it causes amplification of genes, deletion of genes, and many base substitution mutations. And I serve on this panel and also for the Carcinogen Identification Committee panel reporting to OEHA.
Great, thanks very much, Joe. And I'm Cort Anastasio. I'm a professor at UC Davis and an atmospheric chemist and the chair of the panel. Okay, if we go to the next slide, Arash, we have 5 items on the agenda today. First, we're going to be talking about the new reference exposure level document for trimethylbenzenes. Then we're going to go to an update or correction for the cancer inhalation unit risk factor for cobalt sulfate, which there was a cancer inhalation unit risk factor document that we examined, I think it was in 2019. So we're going to look at an update to that. We'll then have an informational item on how to speed up the development of health guidance values. We'll then move to an informational item on a recent release of a draft updated cancer inhalation unit risk factor for ethylene oxide. And then Brian's going to give us an informational update on the community air protection program. And then that'll be the bulk of the meeting. We'll just have a few minor items at the end of that. Okay. For any of the items, you can submit written comments. And to do that, Arash has the link up here and the QR code. So you can submit written comments through either of those 2 methods. And then for the final item on our agenda, the community air protection item, we will be taking oral public comments for that, and we'll have instructions about how to do that when we get to that item. So that will be our last item, and we'll take public comments on that, oral comments at the end. Okay, we're going to move now then to our first major item, which is the trimethylbenzene REL. So Office of Environmental Health Hazard Assessment, OEHA staff will present a draft document that summarizes the development of non-cancer acute 8-hour and chronic inhalation RELs for trimethylbenzenes or Tmbs. To remind you, RELs are airborne concentrations of a chemical that are not anticipated to result in adverse non-cancer health effects for specified exposure durations in the general population, including sensitive subpopulations. OEHA is required to develop guidelines for conducting health risk assessments under the Air Toxics Hotspots Program, which is Health and Safety Code Section 44360B2. And in response to the statutory requirement, OEHA developed draft RELs for Tmbs, which were posted on January 27th, 2023, which started a 45-day public review period during which 2 public workshops were held. And there were no public comments received during the public comment period. So I am now happy to introduce Maura Sullivan, who's a toxicologist from OEHA's Air and Toxicology Risk Assessment section, for her to give us the TMB REL presentation. Thank you, Maura.
Thank you, Cort. Good morning, all. I'm going to share my screen here. Did everybody see this yet? Can everyone see that?
Not yet.
No.
It's not good. Let me escape. Hang on one second. Let's try this again. For some reason, it's not showing up. That's what I was afraid of. Court, it's not showing up for some reason now. It did on the test, so
Does someone else have your slides?
yes, yes, they do. But let me figure out why this isn't working.
Oh, wait, I see Arash has started to share.
Thanks, Arash. I'm having trouble with this again.
No problem. Does it look good? On your
Yeah, it
side?
looks good.
It does. It does. Thank you. Okay, good morning, all. My name is Maura Sullivan. I'm a toxicologist in Conan Christian's section. And I'll be presenting this morning on the trimethylbenzene reference exposure level technical support document for the derivation of cancer RELs. So let me just dive right in here. Next slide, please. Trimethylbenzenes exist in 3 isomeric forms. And the 1,2,3, 1,2,4, and 1,3,5 trimethylbenzene. Next slide, please. The molecular formula is C9H12. These are volatile aromatic hydrocarbons. They're clear, colorless liquids at room temperature, nearly insoluble in water. They have low vapor pressures and high boiling points. Next slide, please. Tmbs occur naturally in petroleum deposits and are common components of petroleum refinery distillation fractions such as white spirit, high flash point naphtha, and gasoline. They're also emitted by steelmaking facilities and coal-fired plants. Other emission sources include construction, cement, paving mixtures, asphalt, and metal coatings. Tmbs are found in printing inks, paint solvents, hydraulic fracturing fluids, and as pesticide additives. And all 3 of the Tmb isomers are found as constituents of biogas, and the source for that are municipal landfills. Next slide, please. Trimethylbenzenes aggregated and the 1,2,4 Tmb stationary point source emissions are reportable to the California Air Resources Board under the Hotspots program for 2020, which is the latest year for which we have data. Approximately 1,141 pounds of trimethylbenzenes from 34 facilities were reported, and 55,000 pounds of 1,2,4 Tmb from 485 facilities. This does not necessarily represent every source of Tmb emissions in the state, only those applicable to AB 2588, which is the Hotspots Information Assessment Act. In humans, Tmbs are readily absorbed via inhalation and have high respiratory uptake. Based on their blood air and oil air partition coefficients, accumulation in adipose tissue is expected. In both animals and humans, the 3 Tmb isomers demonstrate similar metabolic profiles. Currently, it's not known which cytochrome P450 isozyme is most responsible for Tmb metabolism. All 3 Tmb isomers metabolize primarily to dimethylbenzoic and hippuric acids. In humans, exhalation of the unchanged parent compound is an important route of elimination. Urinary excretion of unchanged Tmbs is very low. In human toxicokinetic studies following a 4-hour exposure to 25 part per million, 135, the majority of the absorbed dose was excreted in the first 50 hours post-exposure. However, urinary levels of metabolites were still detected 160 hours post-exposure. There's a paucity of viable data for an acute reference exposure level. Human exposure studies consist only of chamber studies, largely conducted in healthy adult males that evaluated sensory irritation, 25 part per million for up to 4 hours. No evidence of respiratory irritation, CNS toxicity, or toxicity was found in these human exposure studies. The data were self-reported. Effects on the nervous system are seen in acute animal studies, and these form the basis of the acute Tmb rel. So acute exposure to Tmbs causes primarily respiratory and neurotoxic effects in animals, and the exposure duration in most of these studies was 4 to 6 hours. There is one animal inhalation developmental study with exposure uniquely to Tmbs that found significant decreases in maternal body weight and food consumption at concentrations of 300 and 600 part per million, 135 and 124 respectively. Significant dose-dependent decreases were also seen in fetal body weights at 600 and 900 part per million, 124, and at 600 and 1200 part per million, 135. The Salenfay et al. Developmental study was not, however, used for the acute REL because neurotoxicity proved to be a more sensitive endpoint, and Salenfay did not evaluate neurological or behavioral endpoints in their study. So the McKee et al. Neurobehavioral inhalation rat study was what was chosen and for the acute REL. It was conducted on 3 consecutive days, up to 8 hours a day. Rats were exposed to 0, 125, 1250, or 5,000 milligrams per cubic meter of 124 TMB, and they were tested after each exposure. Significant increases or latencies were seen in a number of neurobehavioral tests after a single 8-hour exposure to 5,000 milligrams per cubic meter. Significant latencies have been observed in a number of other acute animal studies following exposure to TMBs. So this slide shows you the Salenfay. This slide shows you the dose response data for the following a single 8-hour inhalation exposure. And you could see it's concentration dependent. And this is for latency greater than 6 seconds. Next slide, please. And here is the graphical output from the benchmark dose program, showing concentration on the x-axis and pain response or latency greater than, I'm sorry, this isn't pain response, that's the next, that's the chronic REL. Latency greater than 6 seconds, which is visual discrimination on the y-axis. Next slide, please. So the acute REL is intended to protect against infrequent 1-hour exposures. The benchmark concentration is 1 standard deviation change from the control mean. The lower 95% confidence limit on the benchmark concentration, 1 standard deviation from the control mean, is the BMCL 1SD. So the point of departure is calculated at 709 milligrams per cubic meter. This was adjusted from the 8-hour exposure in the study to a 1-hour exposure. That gives us 1,417 milligrams per cubic meter. Then a human equivalent concentration adjustment was applied, and that accounts for differences in blood and air concentration in rats versus humans. And in this case, the regional gas dose ratio was used to derive the human equivalent concentration for systemic effects. Next slide. The interspecies uncertainty factor was a total of 6. There was a toxicokinetic uncertainty factor of 2, and that's from the technical support document for OEHA when you're using a HEC adjustment. The toxicodynamic factor was square root of 10, and that was due to the lack of toxicodynamic data on the interspecies differences. Next slide. Oops. We lost that. Great, next slide, please. So the intra-species uncertainty factor was a total of 100. The toxicokinetic uncertainty factor was 10 because there's no information on pharmacokinetic differences for TMBs among adults, infants, and children. And the toxicodynamic uncertainty factor is 10 because TMBs are neurotoxicants and children are potentially more sensitive than adults. So that's a cumulative uncertainty factor of 600, and the final value for the acute TMB REL is 2,400 micrograms per cubic meter, or 490 part per billion. Next slide, please. Okay, so moving on to chronic subchronic effects. There were no controlled, human-controlled chronic or subchronic studies or any child-specific toxicity data that was identified in the literature. No occupational exposure studies that had exposure uniquely to TMBs. Occupational studies in workers that are exposed to paint thinners that can contain as much as 80% TMBs do report central nervous system effects, including neuropsychological changes, memory deficits, reduced motor speed, coordination, as well as anemia and bronchitis. And in biomonitoring studies of factory workers exposed to solvents containing TMBs, vestibular disorders have also been reported. So for the animal data, there are no lifetime chronic animal studies for any of the 3 TMB isomers. Subchronic animal studies show largely respiratory and neurological effects. Subchronic inhalation studies in rodents also show organ effects in liver and kidney, hematological, and clinical chemistry effects. The most sensitive endpoint is neurotoxicity. Thank you. Next slide. So the derivation for the chronic reference exposure level that used the Korsak and Rydinsky neurotoxic inhalation study. And the concentration, in this study, concentration-dependent disturbances in pain sensitivity and motor behaviors were seen in male rats following a 6-hour per day, 5-day per week, 3-month exposure to 0, 25, 100, or 250 part per million TMBs. Significant effects on pain sensitivity were seen at equal to or greater than 25 part per million 123 and greater than or equal to 100 part per million 124 TMB. Significant effects on rotorod performance, which measure neuromuscular function, were also seen at greater than or equal to 100 part per million and at 250. Separately, 135 TMB has also been found to result in behavioral disturbances in a related study by the same authors. Okay. So the chronic REL derivation, here it shows the data sets that we used to develop the REL. And you could see there's the 124 and the 123 TME isomer, and that the animals were more sensitive to the 123 at 25 part per million than they were to the 124. Next slide, please. And here's the graph showing concentration on the x-axis and the pain response, the Pollock latency on the y-axis. And you can see the graphical output from the benchmark dose program. Next slide, please. The 123 TMB isomer yields the lowest point of departure. Benchmark concentration, again, is 1 standard deviation change from the control mean, which is 86 milligrams per cubic meter. The lower 95% confidence limit brings it down to 47 milligrams per cubic meter. So that's the point of departure. This 6-day, hour per day, 5-day per week exposure was adjusted for a continuous 24-hour exposure, which gave an adjusted BMCL 1 standard deviation of 8. And then the human equivalent concentration was calculated for systemic effects. Next slide, please. So the chronic REL is intended to protect over a lifetime, including sensitive subpopulations. A subchronic uncertainty factor was added, which is the square root of 10, because a 13-week study is less than 12% of a rodent's lifetime. The interspecies uncertainty factor was 6. Again, because the Heck adjustment was used, the toxicokinetic uncertainty factor was 2, and the toxicodynamic uncertainty factor was a square root of 10 for lack of toxicodynamic data. Next slide. The interspecies uncertainty factor was 100. Again, 10 for toxicokinetic and 10 for toxicodynamic, due to no information on pharmacokinetic differences, and because TMBs, again, are neurotoxicants and children are potentially more sensitive. So the cumulative uncertainty factor in this case was 2,000, and that led to a chronic TMB REL of 4 micrograms per cubic meter. Next slide. The 8-hour REL derivation is based on the same animal study as the chronic REL. It uses the same point of departure, which is 47 milligrams per cubic meter of 123 TMB. And the only difference is the time adjustment. It's adjusted for an 8-hour workday and to represent the breathing rate of workers. All the uncertainty factors are the same as we found in the chronic REL, and the 8-hour TMB REL is 8 micrograms per cubic meter. Slide. So in summary, these are the values for the TMB reference exposure level: acute, chronic, and 8-hour, 2400, 4 micrograms, and 8. Next slide, please. There was a public comment period for 6 weeks from January 27th to March 13th. And public workshops were held both in Southern and Northern California, and we did not receive any public comments on the draft TMB REL document. And this concludes my presentation. Thank you for listening.
Thank you very much, Moira. So we have 2 panel leads for this item, Joe Landolf and then Pam Line. Unfortunately, Pam is sick today, so she won't be joining us, but Joe is here, fortunately. So Joe, would like to start with you, please.
Yeah, first off, I wanted to congratulate Moira for doing such a thorough job, and Lauren Zeiss and the other reviewers, Darren Dodge and John Boudreau. The document's pretty polished, and that's because you have talented and very experienced authors and reviewers contributing to this document. And the preface was great. It was appropriately short at half a page, and it covered everything Leha's required to use to develop the guidelines. The summary summarized all the reference exposure levels for the 3 TMBs, and it indicates the uses of TMB, has commercial usage for service coatings, paintings, printing inks, cleaning fluids, and hydraulic fracturing fluids. They're a component of petroleum refinery distillation fractions, such as gasoline, high flash point naphthas, and white spirit. They're also emitted by steel mining facilities and coal-fired power plants, and they're found as constituents of biogas, as Maura mentioned. It's a great summary of the uses and occurrence of the TMB. The summary of the toxicology of the TMBs is also very good. Maura noted that exposure to TMBs causes adverse effects on the respiratory, hematologic, and CNS systems in animals and humans. This causes acute toxicity, including CNS effects and respiratory irritation. The authors note that chronic effects include neuromuscular, pulmonary, hematologic, and other organ and tissue toxicity. And the author further noted that there were effects on the nervous system in acute animal studies, and this forms the basis of the acute TMBA RELs. There's a nice table on the physical properties, physical and chemical properties, which I always like to see. Occurrence and major uses. The author Maura covered these on these 3 TMBs very well in this section and very concisely, which is appropriate because it's a lot of data. The toxicokinetics was interesting. The 3 TMB isomers are metabolized in similar ways with some differences. As Maura pointed out, we don't yet know the exact cytochrome P450 enzyme that does this. It's possible it's 2E1, which metabolizes benzene, but that's not been nailed down yet. All 3 TMBs are metabolized by side chain oxidation to alcohols and aromatic carboxylic mercapturic acid by hydroxylation to form phenols and are excreted as glucuronides and sulfate esters. I'm going to skip some of this for time. The toxicokinetic studies in humans were covered pretty thoroughly by Maura. High respiratory uptake and accumulation of TMBs in adipose tissue is expected. The partition coefficients, blood and air, water and air, and oil and air were presented in table 5. And a study of Japanese workers indicated that there was a TLV of 25 parts per million. And I'm not going to spend too much time on that. The toxicokinetic studies in animals were also done. They've been studied by inhalation and by oral routes. And the author notes that the TMBs cross the blood-brain barrier following inhalation exposure in rats. And this is probably why you're getting neurotoxic symptoms as well. And there are slight, some marked differences, the author points out, in the kinetics noted between the isomers of TMB, but I'm not going to dwell on that for time. The acute toxicity of trimethylbenzene was covered, and the statement was that there was little or no toxicity in studies in human subjects. Acute toxicity to infants and children, no TMB toxicity studies were found specifically to infants and or children. Acute toxicity in animals, most of the acute TMB studies in animals are inhalation, according to the author of the document. Also, a few oral studies. Acute exposure to TMB causes primarily respiratory and neurotoxic effects. Some effects in toxicity, some differences in toxicity among the 3 TMB isomers, but they're not huge or anything like that. Parameters affected in treated animals include creatinine kinase, increased blood urea nitrogen decreased, and albumin decreased in male rats. Treatment-related effects included increased white blood cell counts with increases in neutrophils and lymphocytes, statistically significant increases in relative and absolute liver weights and relative adrenal weights. Mortality studies, the acute 4-hour inhalation LC50 values of 18,000 milligrams per cubic meter, which is 3,663 parts per million, and 24,000 milligrams per cubic meter, which is 4,882 ppm, were observed. Chronic toxicity, there's not much information on the chronic toxic effects of TMBAs in humans overall. Neither human-controlled studies nor child-specific toxicity data in the TMB scientific literature. Occupational studies, as Maura pointed out, suffer from lack of good exposure data and are confounded by exposure to multiple organic solvents. From German studies translated into English, CNS effects including nervousness, anxiety, tension, anemia, and bronchitis, were found in male workers exposed to several years to a paint thinner containing more than 50% 124 TMB, 30% 135 TMB, and a trace of 123 TMB. Chronic effects of children, OEHA couldn't locate any scientifically adequate subchronic or chronic TMB toxicities. Studies pertaining specifically to infants and children. Chronic toxicity to animals, no chronic animal toxicities were identified for any of the 3 TMB isomers. Table 13 nicely summarizes the adverse effects reported in subchronic TMB toxicity studies in animals. Derivation of the reference exposure levels look straightforward, and these were done conscientiously and intelligently by Moira and checked by the reviewers. And I agree with all the calculations there. I didn't see anything I disagreed with. And the trimethylbenzene chronic reference exposure levels, same thing. I agree with the calculations there. They're laid out pretty clearly, and I don't have anything to argue with about those. I accept all 3 of the calculations that they made. They look pretty similar to me, pretty conventional. So I would congratulate Moira and the reviewers and the chief, Lauren Zeiss, for all the hard work that went into this document, writing it by Moira and reviewing it by Darren Dodge and John Boudreau. And I think it's a very good document. I'm fairly happy with it. Ordinarily, most things that cross my desk get some rut on it. As a professor, that's kind of reflexive, but I didn't see too much to argue with about this one. I was pretty happy with the product. Thank you.
Great.
Very
Thank you
good.
very much, Joe. Sorry, Moira, did you want to say anything?
Thank you very kindly, Dr. Landolf.
My pleasure. Good product.
Yeah, so I'm going to just go around now to the panel members one by one in the order on my screen for any comments that people have. Beata, we'll start with you.
Sorry, I had to find the button. I actually don't really have anything to add, except that I really enjoyed reading this document, and that it's a little worrisome that it seems the facilities over time have been increasing who are putting this out there into the air. And it is a little worrisome that so many consumer proximity substances are actually contaminated with it. So very well done. Thank you.
Thank you kindly.
Thank you, Beata. Paul?
Well, my first question is really for you, Court. Will the panel be receiving the written comments of the other lead who is not here today?
I've asked Pam to email me the comments, and I can definitely send that out to the entire panel. Sure.
Because I don't remember experiencing before a document discussed where the other lead was not available at all, provided with the input. So
Right.
you rely on the lead. So now my next technical question is, do we have the PDF of the document itself in addition to the slides available for reference to questions that I or other panel members may have? If the technical support person has that easily available.
Sorry, Paul, are you asking if Arash has the PDF of the document?
Right, in a form that you can screen share as needed.
Arash, do you have that available? If not, I do.
I do, but not available right now. So if you can share, that would be great for.
So,
Sure.
so Laura, one question, so these are going to come from my memory of having gone through it, but the diagram that shows diagrammatically the chemical structures of the isomers, I just want to be sure that you're following convention, because it seems not to be consistent in terms of where the positions are, starting with 1, 2, and 3, or 1, 3, and 4. The symmetric. The symmetric makes sense to me, but there was one of them was out of place in terms of the orientation of the figure, but there could be a convention that I don't understand.
I will certainly check that. Thank you.
if you know what I mean. If you can show it
I
to the
do.
group, it'll be clear what I'm asking about.
Uh,
That
It looks like it's on page, it's line 172, table 1.
172, got it.
Can you show that?
Yeah, give me a second here.
It's actually page 1. Yep.
Yeah,
So I see what you're saying,
yeah, it doesn't make sense to me.
that the orientation isn't correct on the way it's put
On the-
into.
Yes, it has to be either the first or the second row. It doesn't make sense how that can be 1,
Okay.
2, 3, and 1, 2, 4 because the 2 position is not the same.
Got it.
Okay, and then
Yes.
I was also confused by the table that had the hotspot releases, which had one listing for total trimethylbenzene and then for one of the isomers.
Okay, and what specifically was confusing?
Confused me is that the totals for the values, the weights for the total were less than the weights for the one isomer, for the 1,2,4 isomer.
Right. So this has actually come up with our in-house reviewers as well. And we did reach out to the California Air Resources Board in regards to this. And yeah, and it's not entirely clear. It's not a mistake. It just has to do something with the reporting.
Well, I would clarify that then, because
Sure.
if your people were confused by this and I was confused by this, right?
Yes.
Uh,
Let me make a note of this.
I actually made me wonder if it's in thousands of pounds on one and just in pounds on the other.
Right.
But it can't possibly be less, for the total.
And so let's just look at this. So are you on table 3A or 3B? Which one are you?
Well, 3B shows values which are higher than 3A, unless I'm reading. Or maybe no, maybe not. I don't know. Yeah, isn't it 55? Like the last row, isn't that 55,839
Right.
for the isomer and only 1,141 for alt combined?
Yeah.
How is that possible?
I think it's just the way it's reported. So they either
Well-
report it as TMBs or they report the 1,2,4 isomers separately. And the aggregated TMBs are not exclusive to 1,2,4, but they can include 1,2,4 or they cannot include 1,2,4.
And then do they not report for the other two? I'm sorry.
No, they do not. Nope. The
Well-
program only requires emissions reporting either aggregated or for the 1,2,4 isomer specifically.
Then this is very, very misleading. And I would either eliminate table 3A and say you don't have good data for total, or reverse them in order and say these data are not reliable because we don't know what they mean, or however you want to handle it. But I would
Okay.
do this way. That would be my recommendation. Because your own
Okay.
people were confused. I was confused.
Sure. Well, or I think it could at least, it should come with a little bit more text and explanation.
Yeah. And then another thing that I think needs to be stated a little bit more explicitly is you allude to the fact that the test for trends were significant.
Yes.
But like in the key table, that's part of the development of the acute exposure limit, where you have an asterisk for the one row, which is the pairwise comparison of the highest value to the control.
Is this a derivation section?
Yeah.
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 Okay.
Or can you go to that?
Let me just
Yeah,
get
can you give me a page or a line number?
so that's going to be it looks like page 57. That's the acute reference exposure level. And the table is actually on 6.
Page.
No, that's not the derivation section. We're almost there.
Yeah,
Are
it
you
just
there?
follows that, doesn't it? The following pages. Past the development, where you talk about benchmark dosing and all that.
Yes, table 15.
Mm.
Yes.
Beyond table 15, it's got to be, because this is about the not about the development.
16?
No. Keep going. Yeah. I think.
That I discuss a clear dose response trend in table 17.
Right. What are the asterisks? Means less than 0.05 compared to
Control.
control. Is that right?
Yes.
Uh,
Statistical significance.
right. But isn't, if you did a trend, shouldn't there be a p-value for that?
You're breaking up. It was hard for me to hear your question.
As a statistically significant test for trend, shouldn't that p-value be presented somehow?
Well, we didn't do a trend test. We were just referring to that there was a clear dose response there.
Well,
That
maybe Dr. Ritz would like to comment, but I would have to say that from a statistical point of view, you can't say one as a kind of a narrative. If you mean it, where's the statistics to back it up?
Sure.
I might, if I could just briefly interject, if you want to appropriately draw that distinction, you might say data sets are included if they show a clear observed dose response trend. And that would indicate that you're not doing a formal test.
But why wouldn't you do a formal test? I mean, wouldn't that support your argument?
Yeah, you certainly could. If you don't have access to the underlying data, we could talk about how to do that from these summary statistics.
And then can I ask a question about something that occurred in an earlier table with the same study, where it was referred to that there was forelimb weakness at the 125 concentration?
Yes.
That's never alluded to again.
Right. Because the authors of that study discounted that.
I thought they discounted the other thing which they saw at the
that it gave them additional strength. Yes. Okay, so that's line 982 on the McKee study. And there was that one finding. I think the finding was
forelimb something.
it was observed in the low exposure group only after the 8-hour exposure period. The authors state the finding is not treatment related because there was no dose response observed.
Because they didn't have it after the second dose.
Well, right, they didn't provide the data after the second exposures, but on the third, they don't see that effect. And so you see that a lot with solvents where you'll see an effect at the lower doses, and at the higher doses, I think it's because it's induced metabolism and the elimination has increased, that sometimes you don't see the same effects at the higher doses. And that's pretty consistent in a lot of the studies I looked at.
I'm not arguing that you use that as your endpoint, but I do think you need to comment, since you have to spend so much time in the reference development about the study, should at least clarify that why you couldn't use that or didn't use that,
Sure.
because it kind of is in the first part, but not in the second part.
Okay, yeah, and I was concerned that we didn't have the data, nor could we get it for second day exposures. Not that it's relevant for the acute per se, but it would have provided me with more information so that I could see what was happening, but I can't.
So I think it's fair game to comment on that, because somewhere else you talked about the data weren't available. So
Correct. Yeah, in the derivation section, I allude to it again, I think, yes.
and then can you just clarify why we're using an 8-hour study for the acute, but we're not using the 8-hour study to inform the 8-hour exposure?
Right, because the 8-hour exposure is a chronic exposure. It's not a one-time exposure. That would be that they would be exposed 40 hours a week for, a lifetime. Their working day is 8 hours.
I see. Okay, thanks. That's helpful. The other, and then none of these other things are that major. To me, the most major confusion was the thing about that we already talked about the hotspots, and it's relevant to Dr. Ritz's comment about the public health relevance of this group of chemicals, because they're not trivial releases. I think it would be helpful if in the narrative where you talk about what the sources of exposure are, that Dr. Randolph alluded to as well, there's some exposure scenarios that you then talk about later in the text, which weren't really clear to me from that narrative at the beginning. The most obvious to me was the one good human case report with the scintillation fluid exposure. And you say scintillation fluids are typically 100% trimethylbenzene.
Right.
But that was never mentioned at the beginning, that in terms of other specialties. So it's good to be.
Not mentioned in the beginning in terms of.
You talk about it's used it appears here and it appears there and these other applications. But then you have an application which is so blatant that you refer to it in the body of the text. So I think it would be good just to be consistent, even if it's a little bit pedantic, to include some of it, if that one and if there are any others. For example, there's mention of asphalt somewhere later as a source.
Okay. My only question is where a reference exposure level is intended for the public. The scintillation fluids is a occupational exposure, for lab workers. So,
well, you've generally been quite broad in saying where things are used, and don't say, well, I'm not going to mention this because it's only occupational. So
okay.
I don't know. It's up to you. But I reacted when I saw certain places, and I said, well, gee, I didn't not because one of the useful things about this group of chemicals about talking about it is it's kind of a sleeper. I mean, I don't know what the other panel members think about it, but I was like, really? this is in all those things. This is 50% of white spirits in some cases.
Yes.
You know, it just, I was taken aback, and it was useful, educational. I don't, maybe Dr. Ritz wants to comment.
I'll go back and take a look at
Yeah.
those examples.
Yeah. And then a final question. And there was a Canadian paper that's fairly recent, and you may even have alluded to it in different contexts, where they looked at trends over time in biomonitoring results for various chemicals.
Mm-hmm.
And one of the isomers had dropped considerably. I think it was the symmetric, the one, is it the 1, 3, what's the symmetric one? 1, 1, 3, 6.
135 is
135.
yeah.
Whereas one of the other isomers was one of the few biomonitoring environmental chemicals that had actually increased over time, had a sharp increase.
We
Do you know
did
that paper?
Yeah, we did include the Canadian biomonitoring study. I don't know if it's the exact one that you're referring to, and
Well, must be, right?
I think so. And the reason they saw a drop was they related it to air pollution, to gasoline.
And why did they see the increase in the other?
Yeah, that's interesting. I don't know if that
I
has to
think
do with
I
the
would-
formulation.
I would
But
comment on it because it's relevant to California. If the
okay,
uses and applications are changing, it could have implications. I just thought that was a really interesting observation. If you're already citing that paper,
sure.
I would say, so those are, that's my shtick.
Thank you.
Thank you, Paul. Joe, did you have a follow-up on something Paul just discussed?
Peripherally, if you want to keep going with Paul's thoughts, it's.
I think Paul's done, but
I'm done.
Okay.
I'm done, Joe.
Okay, thank you. Moira, I had a question. I would predict that, you know, when you add these compounds to animals or humans and you get some damage, that it eventually goes away as the compounds get metabolized and come out in the urine. Is it a reversible neurotoxicity, or does it persist if you?
It does in at least one of the studies on the neuromuscular function, which is the rotorod test. It did persist when they retested the animal several weeks after the final exposure.
And
Yeah.
did it persist completely, or was it decaying in its effect?
They didn't give that level of specificity. I think they just said that, but I can go back and elucidate that if there's additional information. But I know in the vestibular disorders, like in humans, that is not recovered. Now that's not just unique exposure to TMBs, but TMBs make up a large percent of the formulation. But in some of the tests, like in the McKee acute test, they did find that after the cessation of exposure, that the animals did revert back to full functionality. In, for example, on the latencies in the task reward paradigm analyses. But I did notice that they were persistent, and in the Salin phase study, which is the only developmental study with unique exposure to TMBs, those animals were impacted in terms of fetal body weight. So there are persistent effects.
Thank you very much. You might want to mention that somewhere. I'll make you a note for that in the written comments, but you might want to point that out.
Thank you. Okay.
Thank you.
Do we know anything about the age of the animals tested when they were tested? The ones that didn't revert?
Yes, those animals, I think they were 5 months on the rats.
Yeah. Because then you're getting, when you get into older animals, you're getting into the possibility of neurodegenerative disorders. So you would worry about elderly being exposed.
Definitely. Yes.
Okay, let's move on to Karen. Karen, comments?
No additional comments from me. I'm happy to help with any technical issues afterwards, if there are any.
Excellent, thank you. Yeah, Moira, if you want to look at statistics of trends, Karen is your person.
Perfect. Because that's not my superpower. So
Happy to just briefly chat anytime.
Yeah,
thank you very
great.
much.
Thank you, Karen. Okay, next, Ahmad, comments?
Yeah, this was a really nicely prepared report, and I enjoyed reading it. I was personally, I was interested in learning about the half-life of this compound, either the isomers or the aggregate form of these Tmbs. And I went through the document, and there were quite a bit of scattered information here and there, but I was wondering, Moira, perhaps you may comment on that, if this lack of information about the half-life of this compound is because it hasn't been well studied, or is it a particular reason? Because both the half-life of this compound in blood and CNS, especially in CNS, is very crucial, since most of these animal studies have done assessment of neurobehavioral performance. So it's important to know how long these isomers, for example, stay and exist. And since some of these tests were done perhaps hours after termination of exposure, one would want to know what is the time frame of elimination of this compound, particularly from CNS. I believe for your derivation studies, you have used the McKee study, which is an 8-hour exposure. And I understand that the assessment was done like about within 1 hour after determination of exposure, if I remember correctly. So is it consistent with the elimination half-life of this compound from CNS in that?
That was one of the concerning aspects of the McKee study, because the half-life is 1 hour on these acute exposures, and they waited an hour after cessation of exposure to test those animals. And so I called that out in the document, just because that, that is troubling, that those assessments were supposed to be conducted right after the exposure ceased, and there shouldn't have been a 1 hour wait on that. But so that was concerning, especially when you're only looking at a 1 8-hour exposure, and we didn't have any data for the second day. Not that we use 2-day exposures for an acute, study, because we're really looking, we really don't want to look at an exposure over 24 hours for an acute value. But nonetheless, it would have provided, as you're saying, some of this critical information on toxicokinetics. And
thank you for mentioning it. And of course, when you're doing large-scale animal studies, sometimes it's logistically not feasible to do all these measurements right away, but perhaps it will be helpful to kind of make a note of it when you're reporting your results, so that would be a potential limitation of the study. And the other thing that I wanted to mention was with regard to table 3A and B. I think Paul already indicated one of the points with regard to the total emission. I think it's page 4 of the document. And here, what I see is the point source emission rate from different facility for both aggregate Tmbs and the individual isomer 1 to 4 Tmb. I was trying to make a sense of it once. The first thing with regard to the total emission, which was a little bit confusing based on the numbers. And the second thing, I was trying to see why there is so much fluctuation in the total amount emitted. Is it because of the not reporting in certain years, or certain businesses being shut down, or perhaps you might know something about it, because there is hardly any correlation between the number of facilities that have reported and the total emission? Or is there any other reason, for example, they have done certain, there has been some technological advances by which this emission is reduced that I'm not aware of?
So I'm wondering if that's a question for the California Air Resources Board, because I'm not, an expert on facilities reporting. I just collected the data from them. I don't have that level of specificity of information, but if you feel that this should be fleshed out more, certainly I can make a note of that.
Well, it was out of my curiosity. I wanted just to get a better understanding of this, this table, but I leave it up to your best judgment, however you feel like it.
Okay. And I'll write that down. Can I direct your attention to one thing that you alluded to, and ask you if you think this is sufficient? On line 1859 of the document, I did list the limitations going back just to the McKee study. I did list that the authors state, based on previous pharmacokinetic work with TMBs, the hydrocarbons have half-times in the CNS of approximately an hour, and that the visual discrimination performance testing was completed within an hour after termination. So is that sufficient to what you alluded to before? Where you said lack of information about half-life, how long do the isomers stay or exist? What is the time frame? Or did you want me to see if I can tease out, not necessarily from this study, but any of the other studies that looked at CNS effects?
I think this is sufficient, but since you have major headings throughout the document, perhaps this information could be included under a subheading so that it becomes more visible.
Okay. Thank you. Thank you.
Thank you, Ahmad. Any other comments?
No, that is it. And congratulations, great work.
Thank you very kindly.
Great, thanks, Ahmad. Kathy, any comments?
No, thank you for the good work. And the comments I had have been made already. Thank you.
Thank you.
Okay, excellent. If I'm not mistaken, I believe all panel members have had a turn, but if I'm...
Yeah. Or I just have one other thing I forgot to ask about.
Sure, go ahead, Paul.
Is the implication of a lack of any chronic data equate to there never having been any cancer endpoint animal 2-year studies?
Right. So there is one study that was not well conducted that did evaluate carcinogenicity and had no positive findings. I was overruled on including that piece of information.
Okay. And when you say it had no chronic findings, you mean not just no cancer outcomes, but no adverse outcomes of any sort?
It was a very poorly done study, and I don't I can't recall if they alluded to whether there was any mortality or any other effects, because I was asked not to pursue that. So I don't. I could go back and yeah. But there was nothing
right.
else in addition to that
Right,
very
right.
poorly done study. No.
Well, that's pretty shocking for such a, I don't know if ubiquitous is
Yes.
the right word, but
Yes.
for this nature, it's shocking to me.
I agree. I think the lack of mode of action and the lack of knowing which isozyme, I myself was shocked that a chemical that is used to this degree has not been characterized far better than it has.
And when you went to, it's a slightly different question of the same genre. When you went to the TLV documentation, American Conference of Industrial Hygienists TLV documentation series, they haven't ever talked about this chemical?
Yeah, they have a 25 part per million, I think, is the ACGIH on the trimethylbenzenes, and I think it's to do with irritation.
And there was nothing in there that you didn't capture yourself, because sometimes they have industry stuff. That's what I'm asking. That's not
Okay.
published data.
I could take a deeper look at that.
You might want to. And assuming that the higher ups that said you can't talk about the bad carcinogenicity study are part of this discussion or will be privy to it, I would agree with you that it's worth at least saying there's been only one openly published cancer study that was not well done and could not be used.
Yes.
Wasn't useful to us.
Well, my concern was that you or the public would ask about it, and I just, yeah, I think it's worth.
Yeah, I maybe the other panelists should comment, but I would, and in particular Joe, I think that I would support at least saying it's out there, but not useful because of its quality.
Okay. Yeah. Okay. Thank
Karen?
you.
Yeah, this is a slightly different comment, but I just want to note on the ubiquitousness of exposure to these compounds. So this seems like a potentially very useful report. And also to note that the household surveys show potentially chronic exposure levels well above, for a certain proportion of the population, show chronic exposure levels, at least up in Canada, well above this REL for chronic exposure. So I think this is a potentially very useful report.
Thank you. Yes, that's correct. The Canada study does show that they are above our microgram per a cubic meter RELs, and associated with asthma. At least the solvent exposures are, of which TMB forms a proportion. And those are indoor values largely. So of course we're dealing with the Air Resources Board and stationary sources and emissions from stacks as opposed to measuring indoor air. And those indoor air values are largely the result of tailpipe emissions. Cars. So.
Okay. Yeah, that's a good point, Karen. Beata?
Yeah, exactly. That was also my reasoning for making that first comment, that people are actually breathing this as at these kind of levels and indoors. But coming back to the neurotoxicity, I'm a little, I don't know, it may not belong here, but when I saw that ROS and RNS, reactive nitrogen species and oxygen species, are increased in the brain, and that also dopamine and noradrenaline and some serotonin derivatives are all increased, then, my warning lights go on towards Parkinson's and neurodegeneration, because you find, and other possibly Alzheimer as well, because you find all these proteins nitrosated that are aggregating in the brain for these neurodegenerative diseases. I don't know how and where you would mention any of this, because this is just, these are animal studies and they're only very few, but it's kind of worrying me that, you know, you're seeing these kind of events that we know are part of what an older brain shows when they develop these disorders.
Okay.
And I wonder whether that deserves any mention, maybe even just a sentence.
Okay. And of course, we do account for sensitive subpopulations in our values. So on the toxicokinetic and dynamic uncertainty factors, they're larger because we're accounting for sensitive subpopulations. I don't know that I specifically, I don't think I did allude to elderly adults.
Yeah, I get that, you know, sensitive subpopulations are taken into account, but they're never mentioned. We mention neurodevelopment, but we are not mentioning the other end of the spectrum. Maybe it's worth at least mentioning.
Thank you.
Thank you, Beata. Moira, I thought it was also a very well done document, so thank you for that. I had just one, well, I had a couple minor comments I'll email to you. And I had one that's it's also a minor comment, but I just want to point it out. In the beginning of the document, I think you were typically using ppm as your primary measure of exposure, and then you'd have milligrams per cubic meter in parentheses, and I got used to that. And then at some point in the document, you switched, and you had milligrams per cubic meter as your primary, and then ppm was in parentheses, and all of a sudden I had to completely shift my worldview. So it would be very helpful if you could just pick one, you know, either one of those as your primary exposure measure.
Okay.
Put that first always, put that in graphs, you know, like your benchmark or response graph, and pick one unit for the primary and then have the other one always as secondary in parentheses.
Thank you.
And Vincent, I can see you're raising your hand, but I have no way to have you speak. There's no way to allow you to speak, so I'm sorry.
We are not accepting oral comments on this item.
Yeah, Vincent's actually an AWIHA guy, but since he appears to be just general population.
Oh, I can allow.
Oh, you can allow. Okay, yeah, let's allow Vincent.
Okay, sure.
Let's see what he wants to say.
Please, you can send the invite to us. Thank you.
Vincent, you can unmute yourself.
Yes. Hello, I'm sorry. I didn't really mean to raise my hand. I think the cursor just got caught on the raised hand button, and after a bit, it raised it automatically. Sorry about that interruption.
Yeah, no problem.
Okay.
Paul Blanc here. I want to circle back to one other thing about to follow up on the vulnerable populations and the rationales. And it's mentioned that, and uncertainty factors, it's mentioned that the children would be vulnerable because of the neurological outcome. But elsewhere you allude to asthma in a couple of different contexts. You just mentioned in terms of the Canadian study, and then in the dermal data things, and you know, the authors posited about they didn't look at the lung, but the lung cells might have the same response. So typically we have included respiratory asthma is also sort of triggering the childhood vulnerable population. So I don't know whether for consistency this is an OER. You know,
So
right.
So my thinking on that was that because those exposures where they saw an increase in asthma or persistent asthma, and it implicated, you know, TMBs were part of the mixture, but it wasn't unique exposure. So one couldn't really have a causal type of assessment there. There is one animal study that deals with respiratory irritation, and so there's also occupational exposure. So in our technical support document for OEHA, the sensitive subpopulations are if it is a neurotoxicant or a respiratory toxicant, then we include extra factors. So it is folded in, but are you suggesting that you would like me to actually just add that?
Parenthetically, I'd say, predominantly we were adding this factor in predominantly for neuro reasons, and there are also respiratory.
Okay.
Not to mention, however you want to say it, because when you don't say it, it could be taken to imply that you're so discounting the respiratory that it doesn't exist or something. But it really is. I don't feel strongly about it, but it struck me. I forgot to mention it earlier when I was reading this stuff that, neuro, but what about respiratory? Because you talk about it.
Sure. I can certainly run that by EO and see if we can just add that. Yeah. I think I had it in earlier iterations.
I think you do mention it at the very end when you talk about differential sensitivity of children, but it's kind of buried.
Yes, I'm sure I make some reference to their higher breathing rates and greater surface area. And I make some reference to
on line 2114, you talk about it. I don't know if that's enough to address Paul's comment.
Yeah. Right, starting at 2108. I do say at line 2108, additionally, individuals with pre-existing respiratory conditions such as asthma or allergies may be more sensitive to the respiratory effects resulting from exposure to TMBs. And that's under the section evidence for differential sensitivity of children. Is that sufficient? Line 2108.
I would also put it in where you talk about the calculation, because that's where, that's what your justification for the additional factor is, because of neurologic effects, which would be relevant to children. So I think maybe it's overkill though, but that's where I would have expected the asthma comment to be also.
I think it's just because we didn't have any data, but sure.
No, I don't feel strong.
Okay, great. Any final comments from the panel? If not, my reading of the document, as well as my understanding of everyone's comments, is the comments are fairly minor. So I propose that Moira and other OEHA people revise it and then just send it to me, and I'll read through it and then give the final approval. If anyone else would like to take a look at the document that's revised before it gets approved, let me know, and I'm happy to include you on that chain, but otherwise I'll just deal with it.
But Court, can you include in the minutes that your review will also include the written comments of the other lead?
Yes, good point. Yes, I will do that. Okay. Okay, great. Well, thank you very much, Moira. We appreciate your work on this.
Thank you kindly.
We are running about 10 minutes early, which is just how I like it. So we're going to take a 10-minute break now, and we're going to reassemble at 11. So Darren, we'll be having your Cobalt presentation at 11 instead of 11:10. So I'll see everyone in 10 minutes. Thank you very much. Okay, welcome back. Panel members, if you could turn on your camera so I know you're here so that we have a quorum, that would be very helpful. Okay, I think we're set. Darren, are you ready?
Yes, I'm ready.
Okay, and Arash, are you ready?
I'm ready.
Fantastic. Darren, thank you for being here. So our next item is a review, or an update rather, to the inhalation unit risk for cobalt sulfate hexahydrate. So Darren's going to present a draft document that corrects the cancer inhalation unit risk factors, or IURs, for cobalt sulfate heptahydrate and water-soluble cobalt compounds. Cancer IURs are used to estimate lifetime cancer risks associated with inhalation exposure to a carcinogen. For the cobalt sulfate heptahydrate and water-soluble cobalt compounds, OEHA corrected and updated the conversion factor used to normalize for the content of cobalt in cobalt sulfate heptahydrate, and corrected a separate error in the final derivation of the current IUR value that was published in 2020. The draft of this update was posted on May 5th, and that commenced a 30-day public review period, which included 2 public workshops. And Darren, perhaps as beginning your presentation, you could indicate whether we received any public comments or not. So with that, I'd like to introduce Dr. Darren Dodds, staff toxicologist from OEHA's Air and Toxicology Risk Assessment section. Thank you, Darren.
Thank you, Dr. Court Anastasio. Aresh, could you go to the next slide? Okay, this update or correction to the IUR is for cobalt sulfate heptahydrate. As Court said, and we have 2 corrections. The first was the update in response to a correction made recently to the NTP report for cobalt sulfate heptahydrate. The second is a correction due to a calculation error on our part. Next slide. Now, as some of you may recall, there was a cobalt and cobalt compounds cancer IUR factors document that came out in October of 2020. The SRP, I believe, reviewed this document in 2019, as a court alluded to at the beginning of today's SRP meeting. In this document, we derived an IUR, or inhalation unit risk factor, for cobalt metal and poorly soluble cobalt compounds. This IUR was 7.7 times 10 to the minus 3 per microgram per cubic meter. This can also, the units can also be referred to as micrograms per cubic meter to the minus 1. We also, in the same document, derived a IUR for cobalt sulfate heptahydrate and other water-soluble cobalt compounds. This IUR is 8.6 times 10 to the minus 4 per microgram per cubic meter. And this is the IUR that we are updating. We are not changing the one for cobalt, metal, and other poorly soluble compounds. Next slide. In 2022, the NTP, or National Toxicology Program, published a correction in Toxicological Sciences. This is for Technical Report 471, which is specifically the 2-year rodent study for cobalt sulfate heptahydrate. In it, they noted that the concentrations they were using in that report actually were expressed as the anhydrous salt of cobalt sulfate and not as cobalt sulfate heptahydrate or even the hexahydrate as was referred to in the document. So this changes our IUR in and of itself. Next slide, please. So to clarify here, there's a couple of things I want to point out for the cobalt sulfate exposures in the National Toxicology Program, or NTP, 2-year rodent exposure study. The first point is that an aqueous solution of cobalt sulfate heptahydrate was aerosolized for the exposures of the rodents. That's why we refer to the exposure study as a cobalt sulfate heptahydrate exposure study throughout our document as well as NTPs. However, in the exposure chambers themselves, the rodents were exposed primarily to the hexahydrate form. And so in the process of aerosolization, there was a loss of a water molecule. And then the exposure concentrations used in the NPT study of 0.3, 1, and 3.0 milligrams per cubic meter are expressed as the cobalt sulfate anhydrous salt and not as the heptahydrate or the hexahydrate as stated in the NTP report. Next slide. Now, because the cobalt ion is considered to be the primary factor for cancer risk, our calculated cancer slope factor, or CSF, was normalized to the content of cobalt in the IUR document from 2020. And this is done by taking the molecular weight of cobalt, which is 58.9, divided by the molecular weight of what we thought at the time was the hexahydrate, 263.1. And this gives a molecular weight fraction of cobalt of 0.22. Now, because of the update or correction in the NTP study, we express it as the anhydrous salt. The actual molecular weight fraction should be 58.9 over 155. And this is a molecular weight fraction of 0.38. So ultimately, this would change the cancer potency of the IUR by 1.7x, or 1.7 times. Next slide, please. Now, this other correction we need to make was due to a calculation error on our part. In the final calculation of the cancer slope factor, the cobalt normalized CSF was corrected to show that the molecular weight fraction of cobalt in cobalt sulfate is divided into, rather than multiplied by, the cancer slope factor. So the correct way to express this cobalt normalized cancer slope factor is 13.41 per milligram kilogram day divided by 0.38, not multiplied by. So this resulted in a updated cancer slope factor of 35 per milligram cobalt per kilogram day. Our previous cancer slope factor, cobalt normalized, was 3.0. So we're increasing the potency by over 10-fold here. Next slide. In the final calculation, we get to the inhalation unit risk, or IUR, and this is done by taking the cancer slope factor normalized to cobalt, multiplied by the 20 cubic meters per day, which is a default factor for adult intake of air per day, divided by a average adult body weight of 70 kilograms, and including a conversion factor going from milligrams to micrograms. This gave us a final IUR value of 1.0 times 10 to the minus 2 per microgram per cubic meter. Now we could get to this same cancer slope factor of 35 if we were to normalize the cobalt concentrations at the very beginning of our derivation from 0.3, 1, and 3 to 0.114, 0.38, and 1.14. If you start your derivation of the IR with these cobalt normalized numbers, you arrive at the same value of 35 for the cancer slope factor. Next slide. We include the changes to the document in a summary of changes document. This describes where in the cobalt and cobalt compounds IUR document where the changes occurred. Primarily, this is a footnotes added to note that the cobalt sulfate concentration are expressed as the anhydrous salt. We also added a similar or same statement to table legends of the tumor incidence tables. And we modified the final calculation in the text to show the corrected cancer slope factor in IUR. Next slide, please. Now, as Court mentioned, we didn't receive any public comments on the draft cobalt IUR document during the public review period, which was from May 5th to June 5th of this year. We held 2 public workshops as required in the Hotspots Act. The first was in Southern California, Diamond Bar, in May 23rd, and then the one in Northern California was in Sacramento, here in Sacramento, where I am, on May 31st, and this was webcast. Next slide. Okay, that concludes my presentation.
Great, thank you very much, Darren. Panel members, comments? Okay, while we're waiting for the other panel members, let me I just have a couple minor comments. One is, yeah, it's very confusing, right? Where you've got all these numbers without units, and whether you divide by 0.38 or multiply by 0.38. If you actually keep your units on the numbers and put what compound the mass is for, it might help not to do that reverse. You know, if you know it's grams of cobalt per gram of cobalt sulfate, then you're not going to flip it around in the calculation. So just one suggestion. I wonder too, given that this is a very easy mistake to make, have you guys gone back and checked other IURs for metal complexes to make sure that that error hasn't happened previously?
I have not looked at previous documents with that much scrutiny, but we probably should.
Yeah, there probably aren't a lot. So it seems like it would be helpful given that it's an easy mistake to make. And then my last comment was about the revised table. So for example, table 4, I think the footnote A is good. You're talking about concentrations are expressed as anhydrous cobalt sulfate, but it's still a little confusing because the title of the table talks about exposure to the cobalt sulfate heptahydrate. So it's just a little bit more text on that footnote A, something like, you know, the exposure was to the cobalt sulfate heptahydrate, but the exposure concentrations are listed as anhydrous cobalt sulfate. Just to very clearly spell it out so that future people aren't confused about what's going on.
Okay, thank you, Court. We'll do that.
You're welcome. Those are my only comments. Did anyone else have any other comments? Karen?
Yeah, I'm also quite sympathetic to making this kind of calculation error when you're doing a lot of very detailed calculations. My group at the Cancer Center does a lot of those, and we have a lot of people doing them. I'm sure your group has thought about developing templates for those routine computations. So just a page that you can all share that very carefully spells out the computation that you can just paste in these reports that can save a lot of time. And I'm sure you have such a thing. It may be more or less informal. So it might be worthwhile to just have a shared directory where you've got some of those common templates that people have carefully vetted, and you can use them. That can save people time and help with accuracy. Common thing to manage with these big reports.
Thank you, Karen. Good suggestion. Other comments from the panel? I never know when the panel is going to be very chatty or when the panel is not going to have much to say. And apparently right now we don't have much to say.
Well, what
So-
can we say? It's a very technical and just a corrective
Right.
modification.
Right. It seems very straightforward. I mean, it's great that you guys caught the error and that the NTP found the error in the concentration. But right, it's not a lot for discussion.
I also think it speaks highly of the process that when an error was published in the literature, it was caught and the relevant documents were updated. That
Yeah,
shows
that's
good.
impressive. Right. Somebody's reading the literature and keeping track of what's been done in the past for, in this case, an IUR. Yeah. All right. Well, thank you very much, Darren. Appreciate the input and appreciate the correction. In terms of next steps, you laid out in your document all the changes and they all look good. So I don't feel like I need to see the document again before it's approved. I think you can just go ahead and make the corrections that you've laid out and that we've all looked at.
Okay, thank you. Yeah, I'll make the correction that you specified, Court.
Yeah, that sounds great.
Okay,
All right, great. Thank you very much, Darren.
thank you.
Thank you.
Okay, our next item, number 4, is an informational item from OWIHA on a topic that we've discussed a few times in the past, the expedited development of health guidance values. So as we've discussed previously, there is an opportunity to speed the development of health guidance values by leveraging the work of other OWIHA programs and authoritative agencies like EPA. So this is a follow-up to OWIHA's presentations to the SRP on July 9th and October 9th of 2020. And Heather Bolstad, who's a staff toxicologist from OWIHA's Air and Climate Epidemiology section, is going to give us an overview of a possible expedited process for developing health guidance values. So Heather, the floor is yours.
Great, thank you. Good morning. My name is Heather Bolstad. I'm a toxicologist with the Office of Environmental Health Hazard Assessment, or OWIHA. And today I'll be providing an update on our efforts to develop expedited health guidance values for hotspots compounds. So just a little background on hotspots. The Assembly Bill 2588, Air Toxics Hotspots Emission Inventory Criteria and Guidelines Regulation, which I'll refer to as hotspots, was first enacted in 1987 and has been amended several times since. It requires stationary sources to report the types and quantities of certain compounds released into the air, and its goals are to collect emission data, identify facilities having localized impacts, determine health risks, notify nearby residents of significant risks, and reduce significant risks to acceptable levels. It requires reporting of approximately 1,500 compounds. So as you know, OWIHA develops health guidance values for use in hotspots, specifically the reference exposure levels or RELs for non-cancer effects and the inhalation unit risks and slope factors for cancer effects. The SRP has reviewed many of these values and continues to do so, as evidenced by today's agenda. Both types of values are used in hotspots, facility prioritization and risk assessment, and to provide greater impetus for reporting of emissions under hotspots. So they have important applications. However, hotspots assessments to produce RELs and cancer potencies require significant time and resources. OEHA conducts a comprehensive evaluation of the literature, and this process, along with internal peer review, is time-consuming. As a result, draft assessments are submitted for public and SRP review at the rate of about 1 to 3 compounds per year. This pace is dwarfed by the number of compounds on the hotspots list that do not have OEHA-derived hotspots values. Approximately 700 compounds, or half of them, have neither an OEHA hotspots value nor a value from some other agency as identified by CARB. These 700 compounds span a diverse array of chemical classes, as shown here, and include some familiar ones. We are envisioning 3 possible approaches to expedite development of health guidance values for hotspots. One is by simply adopting and adapting recent health values from other OEHA programs, such as the Public Health Goals for Drinking Water, also known as PHGs, or the Proposition 65 values for carcinogens. Hotspots obviously concerns inhalation exposures, and thus the priority would be those values from other OEHA programs that are based on inhalation studies, which is often the case. The second approach is to adopt or adapt values from other entities, such as the US EPA. We presented a methodology for identification and evaluation of such values to the SRP in 2020, along with methods by which they can be adjusted as needed to serve the purposes of an inhalation risk assessment for the general population. Third, computational toxicology and new approach methodologies, or NAMs, may be used to derive values for data-poor compounds. OEHA is in the process of building capacity in this area through collaborations with academic partners and creation of a new section within OEHA, whose aim is to further the development of NAMs-based regulatory values. We will provide updates on these efforts at future SRP meetings. All 3 of these approaches were used by OEHA to develop values for the CARB-led study of neighborhood air near petroleum sources, also known as SNAPs. Our initial focus is on the first approach and to specifically adopt cancer potency values based on inhalation studies from other OEHA programs. We would start with values produced by OEHA within the last 10 years. Now, you may be wondering why we'd adopt a drinking water value for the hotspots program, and I'd like to clarify that point. This is among the things that must be considered when adopting and adapting values from other OEHA programs. I provide examples of 2 OEHA programs here. So the public health goals are drinking water concentrations that take into account drinking water intake rates. Thus, we would not adopt the public health goal itself, but rather the basis of the public health goal. Specifically, for non-cancer effects, it would be the point of departure divided by uncertainty factors, while for cancer, it would be the potency. For Proposition 65, we have 2 kinds of values, one for non-cancer effects and one for cancer. The non-cancer value is known as the maximum allowable dose level, or MADL for short. It is developed for reproductive and developmental toxicity endpoints, and it has a specific definition in that a level 1,000 times greater than the MADL is expected to have no observable effect. The cancer value is known as a no significant risk level, or NSRL, and also has a specific definition in that it is the dose in micrograms per day associated with a 10 to the minus 5th cancer risk. As for the public health goals, the basis of the proposition As for the public health goals, the basis of the Proposition 65 values would be adopted, not the values themselves. For the MADL, the point of departure divided by uncertainty factors selected per OEHA REL guidance would be adopted. For the NSRL, the cancer potency would be adopted. And for the non-cancer points of departure, I want to note that the nature of the critical study would determine whether it would serve as an acute or chronic value. As I said, our initial focus is on adopting points of departure based on inhalation studies. At some point, we will also consider adopting values based on oral studies, which will require special consideration. First, there can be endpoints from oral exposure that may not be relevant to inhalation exposure, such as effects resulting from interference with nutrient absorption or portal of entry effects. The other is that there are endpoints by the inhalation route that may be more sensitive or unique to this route and would be overlooked by using a value from an oral study. Example endpoints include irritation of the respiratory tract, eye, or membranes, as well as respiratory sensitization and lung and nasal tumors. As a result of these issues, we will adopt the most scientifically justifiable health guidance value. Prior to adoption, we need to ensure that the literature published since the value was derived does not contain any potentially influential studies. A possible approach could look something like this. The literature search would begin where the previous assessment's literature search ended. New studies suitable for quantitative dose response analysis would be identified. These would consist of mammalian bioassays of sufficient duration that, in the case of cancer, provide tumor incidences, as well as epidemiology studies with quantitative estimates of both exposure and risk. If there was a high-quality study that was more sensitive or more appropriate than the study used to derive the established value, we would consider updating the value. In the absence of such a study, we would adopt or adapt the established OEHA value. We've identified some first-round candidates for adoption. These include the Proposition 65 cancer values for bromoethane, also known as ethyl bromide, trichloroethylene, and vinylidene chloride. Trichloroethylene actually has a hotspots potency, but the Proposition 65 value is newer and is based on epidemiology studies rather than animal studies. In terms of our next steps, we will start by developing expedited numbers through adoption of cancer potencies from other OEHA programs with an initial focus on recent public health goals or Proposition 65 values. We will release the expedited values for public comment and bring them to the SRP for review. In the future, we will also identify additional sources of health values to add to those identified by CARB. And finally, our new toxicology evaluation section, or NTES, within OEHA will be using NAMs to derive regulatory health guidance values. That concludes my presentation, and I welcome any comments or questions you might have.
Thank you very much, Heather. Panel, comments, questions?
I guess I have just a sort of calculation question, which is, it seems that these numbers that are going to be adopted may already have some uncertainty, some allowances for uncertainty built into them, like the 1,000 times the exposure is still expected not to create any adverse effects. So I just wonder if that should be taken into account. You know, my understanding of the point of departure is that then you make these uncertainty adjustments on top of the point of departure. So I wonder if that's leading to some redundancy, or if you've thought about that.
That's a great point. I will definitely keep that in mind so there's no double counting of uncertainty factors.
Yeah, you know, I don't know how formally you can balance that, but you should at least think about it.
Right. Thank you.
Yeah.
Thank you, Karen. Ahmad?
Yeah, I think in view of what you are proposing to take advantage of already existing report from OEHA or other, groups associated with EPA, it is important for all reports that are being produced to have a uniform section for identifying their search criteria, what kind of literature, what time frame was used to identify literature to be included or excluded in the report. As I recall, some of the more recent reports do include this section, but many do not. So perhaps that is something that you might consider as a group and as an organization for future reports, or even going back and retroactively like insert this section into existing reports.
Okay, thank you.
Thank you, Ahmad. Other panel comments? I have some questions. Heather, can you put your slides back up, and can you show us the pie chart that showed of the hotspots compounds, which ones have health guidance values, which ones do not? Okay, so you got 1,500 compounds. 20% of those have a health guidance value that's been approved. So the WIHA approved hotspots health values, that's not just RELs, but that's also things like the public health goals and the Prop 65, or is that?
No, the 20%, the 293, those are only hotspots values, so they don't include our other values.
Those are official hotspots values. Okay,
Yes.
and then this blue color, does that include the public health goals and the Prop 65, or no?
I believe it does, but it also includes like USCPA, ATSDR, ACGIH, OSHA PELS.
Gotcha. Okay, so some government health guidance value. Okay, so there's a lot of potential here then in terms of increasing the number of compounds that we have on the hotspots list, which we are all for. So that's great. So when Conan presented to us, I can't remember when it was now, maybe 2020, he was talking primarily about using literature reviews of other compound, or of a compound that had been assembled by, say, EPA, and not have to repeat that, not have to go back and recreate that material. But what you're talking about now is going beyond that, right? You're talking about actually using some health guidance values for other programs like Prop 65 and applying those to hotspots.
Yes.
Okay, that's great in the sense that, it really expands the scope of what's possible.
Yes, and it is interesting that many of our public health goals are actually based on long-term inhalation studies. Particularly, for the volatile compounds, just based on the data availability.
That was going to be my other question is, so you're saying a lot of these drinking water standards are actually based on inhalation studies. Wow. Okay, that's great.
So that was actually one of my questions too. I mean, some of these 703 that might be evaluated in water are probably because water is the main source, right? So for PFAS, for example. And it is a different route. Would you then not have to reevaluate what happens if it's in the air and inhaled and gets kind of into the body and into the brain and wherever else in a slightly different way?
We would definitely need to consider the pharmacokinetic differences between the routes, which I kind of alluded to in terms of portal of entry effects, and like some metals interfere with nutrient absorption, which wouldn't necessarily be relevant via inhalation. That sort of thing. In terms of volatility, we would also use the likelihood that a compound would be in the air and inhaled to try to prioritize these 703.
Thank you, Beata. Karen?
Yeah, I guess your last remark is what I was going to, what I was thinking about was, with such a long list of compounds, it seems like it would pay off to put some initial effort into prioritization. And that should be given some thought and structured so that it's transparent and well understood how you'd be prioritizing these compounds. That seems like it'd be well worth the effort, either on the basis of some kind of ballpark estimate of harm, you know, intensity and number of persons, or risk, more like, before you've done the assessment. You may not understand the harms, but your understanding of the risk of major harm. And then I guess the second thing would be, when you're using these pre-existing studies, it might be worthwhile to do a couple of pilot examples and see how much time you actually save. Because the time savings may not be as much as you are hoping if you still have to do a literature review and write a whole report. So that might help also, to do some pilot studies and see how much time you save, and then think critically, is there a way to streamline that, be more efficient in the use of prior information? Just general suggestions.
Okay, thank you.
On a related note, you know, so you go through the compounds that have inhalation studies, and that's very straightforward. But then you start to get to compounds where you have other routes of exposure. And my question is, how do you know whether you're right? So let's say you have an oral exposure, and you do some correction to adjust for that. Are there compounds where you have both inhalation and oral exposures, where you can look at what you would get for a rel from the two routes, and you can see, okay, yeah, if we use the oral, we get this? I mean, I guess the question is, how do you know if you're correct from a non-inhalation exposure?
That is one thing we could do, is look at those compounds that have both, like a cancer bioassay by the oral route and the inhalation route. And I think our cancer potency guidance discusses this. And I believe that the oral potency is generally predictive of the inhalation potency. Inhalation may be a little more potent. I'd have to double check that, but that's something we can look at. And then the SRP actually brought this up when we presented in 2020 on this topic about, for example, missing respiratory sensitizers by using an oral value. And so how we've addressed that is by using the OECD toolbox, the QSAR toolbox, to predict respiratory sensitizers based on the chemical structure, to try to not miss any alerts. And this can also be assessed just based on chemical class, like isocyanates, I'd expect to be respiratory sensitizers. So that sort of thing. So that's a good question, like definitely kind of ground truthing as we go. But one thing to keep in mind is that in the absence of a value, we're assuming zero risk. So there is a benefit to having a value.
Yeah, and I know we've talked on the panel before about provisional health guidance values, where it might be better to just get an order of magnitude number up there, just so that you can start to assess risks from compounds that currently have assumed zero risk. And I think that's another potential approach for, you know, say oral exposure route compounds. Yeah. Well, I can speak on behalf of myself, and I think the rest of the panel will be very interested to see how this plays out, and especially some of the ground truthing as you go along, you know, will help us feel more comfortable, I think, with the approach. I'm also very interested in, I can't remember what the acronym stood for, but the NAMs, right? The toxicological, sorry, the computational approaches to toxicology, because animal and human studies are so expensive and time consuming. that I'm very hopeful that the computational work is going to start to bear fruit. Otherwise, we're never going to get to, you know, the majority of these 1,500 compounds. It's going to take something that's faster even than what you're suggesting right now. Yeah.
Right.
But I'm very encouraging of approaches that can speed up the development of health guidance values. And this is a nice step in that. Any other comments from the panel? Karen?
Yeah, just following on the tiered approach, I think there's a lot of promise there, especially with computational approaches. Those could be a rapid first pass, and then those could be used to prioritize compounds for a deeper dive and validation. That could work very nicely.
Yeah, good point. Okay, seeing no other comments. Thank you very much, Heather. We look forward to getting an update.
Great.
This is
Thank
a
you so much.
very encouraging route. Yeah. Let's see, we're at 11:41. We were planning for lunch next, but instead, if Conan is ready, I suggest we move to the ethylene oxide informational item, and then we'll take lunch after that. Conan, are you prepared to start with that?
Yeah.
Fantastic. Okay, so the next item then, item number 5, is informational item from OWIHA on the recent release of draft updated cancer inhalation unit risk factor for ethylene oxide. OWIHA recently released this draft for public review, and the updated IUR for ethylene oxide is based on current evidence, including human epidemiological studies. The current value is based on animal studies and was developed in 1987 when OWIHA was part of the California Department of Health Services. The current draft, the new draft, was posted on April 7th, 2023 for public comments and included workshops in both Southern and Northern California in May. And OWIHA staff are going to give a preview to the panel on the IUR update. So this is not a formal review for ethylene oxide IUR, but it's a little informational item. So Dr. Kanan Krishnan, Chair of Air and Site Assessment and Climate Indicators Branch of OWIHA, will be giving the presentation. Thank you, Kanan.
Thank you. Morning, everyone. My slides. Guessing able to see the slide on the full screen more. Okay, great. Thank you for the introduction. This is an informational item on the recent release of the draft updated cancer inhalation unit risk factor for ethylene oxide. It's more of a status report, and I just wanted to follow up on the previous presentation I made to the panel on 12th of May last year. Maybe just by way of a very quick introduction, ethylene oxide is predominantly used as a chemical intermediate in producing other chemicals, particularly ethylene glycol, antifreeze. And in California, as in other places, as elsewhere, it is used as a sterilizer for medical and laboratory equipments and supplies. It's also used as a fumigant for agricultural products, particularly when the materials are damaged by heat or other methods of sterilization are ineffective. Ethylene oxide is identified as a carcinogen under Proposition 65, and the U.S. Environmental Protection Agency has classified it as carcinogenic to humans, or a Group 1 carcinogenic to humans, and IARC designated it as a Group 1 carcinogen or carcinogenic to humans, based on limited evidence in humans, sufficient evidence in animals, supported by strong mechanistic evidence or evidence of genotoxicity. A national toxicology program as well concluded that it is known to be a human carcinogen. And we agrees with these conclusions as we present it in the draft that we have submitted for the public review. We agree with these conclusions regarding the ethylene oxide carcinogenicity. The inhalation unit risk factor for ethylene oxide, or IUR, was developed initially in 1987 when WAHA was part of the California Department of Health Services, or CDHS, and was based on animal cancer studies. Since then, the knowledge base has grown and new relevant human epidemiological studies have become available. And that has been used by the U.S. Environmental Protection Agency to update its IUR for ethylene oxide in 2016 after a comprehensive evaluation. In its assessment, EPA used a human epidemiological study for 17,530 workers in sterilization facilities in the US. And their assessment review received public comments and was peer reviewed by the Science Advisory Board. As the chair pointed out moments ago, I made a presentation last year about the possibility of leveraging work from other health agencies. And there are two things. One way of expediting the process, as Heather alluded to, and in this case, leveraging work could potentially also help expedite, but where feasible and appropriate. And we wanted to build upon the authoritative review conducted by other agencies in the following evaluation. And also, we proposed last time when I made the presentation that we would combine the effort with other OHIA initiatives. Because ethylene oxide is also reviewed by Proposition 65 program at the same time as Hotspots program, because both programs developed the estimates using the animal studies during 1987-88. So now we put our efforts together, satisfying the requirements of both programs, effectively, producing a single work group and essentially a single analysis of the data. So the starting point then was as I presented last time, our starting point for the analysis for ethylene oxide was the US EPA 216 assessment document. That was the primary source of studies or descriptions of studies published prior to our IUR development. And also all the studies published until 2016. So our literature search then focused essentially since 2016 or since the EPA assessment. So the review focused on the period of January 2016 to January 2023 to identify the more recent studies for developing the IUR. Well, you will see that when we get to the review of the draft. Just to give you an update of what happened, we released the document on the 7th of April, the draft for public review. Both the Hotspots Cancer IUR, the updated draft value, as well as the proposed updated Proposition 65 NSRL, or no significant risk level for ethylene oxide as well. So both of these values are based on the cancer potency derived from EPA's exposure response modeling and calculated from the occupational epidemiological studies that I referred to moments ago. So more, what does it say? The revised draft value, what does it say and how does it compare with the previous ones? So the more recent human data, as reviewed both by us as well as EPA, indicate that the ethylene oxide is a more potent carcinogen than indicated by earlier animal data. And the updated draft cancer potency for ethylene oxide based on human data is about 38 times greater compared to the current IUR, which was derived in 1987 based on animal data. I put the next 3 slides just to refer to some of the elements in the draft with no intention of getting into any of the details. The draft addresses and recognizes the endogenous production of ethylene oxide because it is produced endogenously in every individual and species, and it contributes to the hemoglobinatic levels as a background level. And it summarizes the ethylene oxide genotoxicity. Once again, instead of reviewing the entire literature and presenting all of the individual studies, we refer to the reviews by the other agencies, in particular EPA and IARC. And then we have included descriptions of only the additional studies that have appeared since 2016, which are also consistent with the overall evidence, or which adds to the overall evidence. And our update is based on the EPA's exposure response modeling or the analysis. So instead of adopting the work conducted by EPA directly, we evaluated several other options as well in terms of modeling the data, and none of the other models would result in a better fit than the model selected and used by EPA. So, and there's no new scientific information since 2016 that necessitated a change to the modeling or the derivation by US EPA. So we concluded that EPA's exposure response model is the most appropriate one for estimating the cancer risks for ethylene oxide. So in the draft, we present the adult exposure-based ethylene oxide, IUR, as I showed you, 3.3 10 to the minus 3 microgram per meter cube. And it is for the combined lymphoid cancer in males and females, as well as breast cancer in females, for the 2 types. And the cancer slope factor, or the inhalation unit risk, IUR, describes the excess cancer risk, that is the risk over and above the background risk associated with ethylene oxide. And the background risk would also include endogenous exposures. So the IUR that's derived is to estimate the excess cancer risks that will be over and above the background risk, including the endogenous. The public review draft was released on 7th of April, and the comment period ended on the 14th of June, day before yesterday. During this period, we conducted 2 public workshops, one in Northern California and one in Southern California. And we had 1 commenter in person in Sacramento and 2 in-person attendants in Diamond Bar. Since then, we have received written comments. At the close of the public comment period on 14th of June, I received 4 written comments by email, and we have received via the website 11 written comments. There may be some overlap of submissions, but we're yet to have the information on it. So in terms of next steps, we'll be reviewing the public comments, and we will develop the response to comments and make appropriate changes to the draft document, and then bring the document, the revised draft, to SRP for review. So hopefully at the next meeting, that would be our expectation. So that concludes my status update and on ethylene oxide and on the process of developing the document that I alluded to last time at the SRP meeting. Thank you.
Great, thank you, Conan. So panel, any comments? Mindful of the fact that we're going to see the full document at a future meeting, but are there any interim comments before we get to that point?
I just have a general, somewhat naive question to help me understand how these documents are used. Given that my understanding, Kanan, is that there's an EPA standard that's already developed, is that right?
Yes, yeah, cancer slope factor, yes.
How do our CARB standards relate to those EPA standards? Are they a California specific standard that's independent, or?
Under the hotspots program, we have the guidelines, methodological guidelines of developing the values, both for cancer and non-cancer. There are some methodological differences in terms of what specific factors have applied. Like when you look at the non-cancer development, there's a sensitivity factor to protect children, for example, that can be up to a factor of 10 separately. As you saw earlier in the TMB presentation on trimethylbenzene this morning. We use our methodological approach and an independent analysis to be consistent with our guidelines.
And does that result that California guidelines are generally more stringent than EPA guidelines? Is that a fair thing, or does it vary? It's just a general question to help me get the context here.
Yeah, maybe I would invite Vince to have a word on it.
Thank you very much. They do differ sometimes. Sometimes California and US EPA standards differ because we've looked at the database at different times. The guidelines, though, that we have, though they're very consistent with each other, sometimes have some slight differences, like on non-cancer, this doesn't apply to ethylene oxide. Our default intrahuman variability factor is 30 rather than 10. But the guidelines are generally very, very similar. Now, in this case, there are some California programs that would give preference to an OEHA value over a US EPA value. And in this case, the OEHA value was developed in the 1980s, before these NIOSH studies became available about 8 to 10 years ago. And it's really not a matter that we think that the value from the 1980s is better. So we did look at the US EPA value very, very carefully. We did a few sensitivity analyses and we determined that it certainly is a better value than the value based on animal studies from the 1980s. And we don't want there to be any confusion that where OEHA is insisting on 30 to 40-year-old animal studies instead. So that's why we're proposing this update to the OEHA value.
Thank you. That's very helpful context. So it's a case where there's an existing value which has been superseded by a more stringent value at US EPA, and it seems prudent to update the OEHA value. That's my understanding.
It's been superseded, but I wouldn't say it's because it's more stringent. It's based on newer information and it's based on epidemiological studies rather than laboratory animal studies. So that's the reason that we feel that it needs to be updated, not necessarily because it's more stringent, though it is.
Thank you for that clarification. I guess a better way to put it is there is an appreciable difference.
Appreciable difference and a better basis for estimating human risks.
Thank you.
And also maybe on the technical front, in terms of the cancer inhalation unit risks, there's a slight difference the way they are developed and used between the EPA and WIEHA. Here, the age adjustment or age sensitivity adjustment is done during risk characterization, whereas EPA does those adjustments upfront. It may sound a bit technical, but so it's not the same. California specific use is not the same as where it's applied is a bit different.
So
Specific.
just one comment, maybe this very detailed study can use as a test case or a model for the earlier project we were talking about for considering, adoption or update of OEHA values based on existing literature, since by doing this comparison, you'll have a very detailed understanding of the methodological differences. Maybe out of this could come a recommendation for interim values that might be adopted from EPA in the case when there aren't any OEHA values. Just suggesting you might take this as a test case for the project we heard about prior to this, of trying to find ways to provide a more rapid process for at least interim values. I don't know how clear I'm being.
I think that's clear, and I think this is actually an example of adapting a value by another health agency, in this case US EPA, rather than doing all the work from scratch of looking at the epidemiology and developing numbers. US EPA used models, and we started with looking at those models, and we did some sensitivity analyses on them and determined that they were, we think, a good way to go for ethylene oxide. So I think it would have taken us a lot longer if there were no US EPA value, but we were trying to use the NIOSH studies. That definitely would have taken us longer to develop in-house.
One last comment. I apologize for sort of going down this rabbit hole, but that sounds great. And maybe there could be a kind of meta report documenting the time savings and helping establish a template for future studies or future adoptions, since this is being done with such care and such thought.
And that's a good comment. I think we'll look into doing that, and as a way of demonstrating that this expedited process of looking at other values in OEHA and other values by other health agencies can save us time instead of developing new values from scratch.
Great. Thank you, Karen. Any other panel comments? Okay, doesn't appear that we have any more. So we are at a crossroads. We have two options at this point. We can take our scheduled lunch break, which was going to be 45 minutes, or we can power through and probably be done in about 30 minutes. So is that, Beata, do you have a question or comment about that?
No, I have a comment because I'm in Europe 9 hours ahead. If you take a break, I don't think I can make it.
Can't make
because
it
it's
back.
getting late.
Yeah, okay, so let me take a vote then of panel. My motion is that we power forward and we try to get everything done continuously, and then your lunch is delayed, but then your afternoon is yours. If you're in favor, yeah, give me a thumbs up or raise your hand. And okay, okay, so everybody wants to do that. I agree. And I just need to make sure though that our presenter is prepared. Brian, does that work for you? Sorry, Brian, you're not muted, but I can't hear you.
Oh, you know what? My mic was off. Yeah, I'm ready to
now I
go.
can hear you.
Sure. Now I'm ready to
Okay.
go. Yeah.
Fantastic. Okay, then I'm very happy to present or introduce rather our last item, number 6. So this is an update on the Community Air Protection Program. So you will remember that CARB staff from the Office of Community Air Protection, OCAP, They're going to update us on current activities, focusing on this year's annual update to the board and the update process for the statewide strategy, also known as the program blueprint. In response to Assembly Bill AB 617, CARB established Community Air Protection Program, CAP, or program. The program's focus is to reduce exposure in communities most impacted by air pollution. Communities around the state are working together to develop and implement new strategies to measure air pollution and reduce health impacts. The panel is one of several groups being consulted about the implementation of the program. And if you want more information about the Community Air Protection Program, you can go to their website. And for this item, the panel will be accepting both oral and written public comments. So Arash, actually, Brian, before we get to your presentation, Arash is going to show an instruction slide about how to make a public oral comment. Arash, you with us? There we are. Arash, can you explain this?
Sure, sorry.
Okay.
So if you want to submit your oral comments, we are accepting oral comments on this item after Brian's presentation. So please kindly raise your hands. You can do it either using the reaction button on the menu that you see on the bottom of your Zoom application. There might be a raise hand, lower hand button directly there, so you don't have to go to the reaction button. And for those of you who are joining by dialing the number in via phone, you can dial *9 to raise your hand, and we will, after Brian's presentation, we will activate your mic and you can provide your comments. The comment time for this item is about 10 minutes, and we will adjust the number of the time based on the number of commenters. Thank you.
Great, thank you, Arash. So without further ado, then I'd like to introduce Dr. Brian Moore, who is the supervisor of community planning section from CARB OCAP.
Thank you. And it's great to see you all again. And I appreciate the chance to update you on our program. So this program update, I'll just split it into two parts. The first will be on our annual program update, kind of looking backwards on what has been accomplished over the last year. And then the second half is going to be on our statewide strategy revision process. So we call that guidance document the blueprint, and we are developing draft versions of our second blueprint, Blueprint 2.0 right now. To give you a little idea where we are in the program. Oh, and again, I should state, I think I forwarded the links to Arash, but we have an annual report out that you all can take a look at, and I can get it to you again if you'd like to see it. That has detailed information on progress over the past year. But just from a high level, right now we have 19 communities that have been selected by the program to develop emissions reduction programs or community air monitoring plans. And of those 19, 18, so almost all of them are developing emission reduction programs. And then we have one that is just doing air monitoring. And as you can see from the list, they're located throughout the state. The right side of this figure shows where these communities, these 18 communities that are developing these emissions reduction programs, are in the process. So you can see that we have a big takeaway is we have 7 that are entering their last year, their 4th year of implementation before they hit that 5-year milestone, where we're going to really take a close look at how those programs are doing. From an incentive side of things, so our program does get a sizable incentive budget to see this program implemented and get early emissions and exposure reductions. So the left side there shows money spent through November 2022 by sector in the community air protection program. So you can see a lot of on-road, locomotive, marine vessels. There's some big investments as well as off-road ag. One thing I did want to call attention to was that top 5 million, it's labeled as community identified projects. These are actually incentive projects that were developed by the air districts partnering with community steering committee members. So community members in these communities came up with projects to address specific community concerns. And that's what that 5 million is there for community identified projects. The right side of the slide looks at those incentive projects and is estimating emissions due to those expenditures. So you can see the way they're split up, we have the green or the teal color kind of showing the emissions that we've seen or estimating to be reduced inside these 19 selected communities. And the gray are emissions estimated to occur outside of these kind of officially selected communities for emissions reduction programs, but in other disadvantaged communities throughout the air districts. So we average around 35% of reductions are happening within the AB 617 communities. But part of these incentives, the point was to see early reductions throughout the state. So that's why we are also seeing those reductions in the gray bar, in the gray section of those circles. So on the flip side to seeing emissions reductions, we also have a really robust variety of exposure reduction projects that have been implemented in these communities. And many of these have been taken advantage of that 5 million in community identified project design. So an example would be like school notification systems, either enhancing them, upgrading them, or making sure they continue. Residential and school air filtration projects have been really popular. And so these are types of projects that aren't captured in the emissions reduction estimates, right? Because we're not really reducing emissions, but we are definitely reducing exposure, especially to sensitive populations like school children. Actually, some of these we do see emissions reductions like paving projects, retrained dust, road dust. We actually can estimate reductions with those types of projects as well. So now I'm going to kind of shift gears, and this next section is about looking forward to how we're going to revise our statewide guidance. So on this slide, on the left side, we have the 3 bills that are now in law that kind of guide the program. So that'd be 617, which was the initial one. And actually AB 197 kind of calls back to Moira's presentation, where that actually led to enhancing CARB's emissions inventories and what we're required to report from facilities on their emissions. So that data is rolling in as well and should help a lot with estimating exposure. And then 1749 actually, 2 main things. It helped extend, if the air district and community and CARB will agree, the time required to create an emissions reduction program. That was a big concern, is that these community members and air districts had 1 year to meet up and develop an emissions reduction program, a SERP, and that just seemed to be too short. You're meeting once a month, that's 12 meetings at the most. So the legislature gave us an additional year if all parties agree. So that's what 1749. And actually also for the larger air districts requires them to post their permitting for facilities, which has also been a data source that many community members have wanted, and it's very helpful. So that kind of helps on the transparency side, that we'll see those permits posted. And then this kind of just indicates that, we take those laws, and then our statewide strategy is just implementation guidance. So CARB's attempt with air district and community partners to take these laws and make sure they happen. And we wrote the first guidance in September 2018. And this September, 5 years later, we're looking to revise that guidance. And we are doing that because statute actually requires us to revise guidance every 5 years. So that would be this September. And a big part of that is just taking all the direction we've gotten over the last 5 years to try to improve the current components of the program, as well as add some new components to help us reach more communities in a more resource efficient way. So this wheel here just shows in the dark blue the requirements and guidelines we've written for in our first 2018 guidance document blueprint. The light blue shows new sections that we have added, and those highlighted in kind of gold are 3 mechanisms or pathways that we are suggesting to leverage CARB resources to get benefits to more communities across the state that are in need, rather than this kind of official, selecting communities, one-off, 1 or 2 or 3 every year. We want to be faster with rolling out benefits across the state. And this is just a kind of a high-level look at our funding. This is one of the drivers of trying to be more resource efficient and nimble with getting out emissions reduction strategies, is that if you can see there, the implementation funds that we get from the legislature have been pretty flat since the inception of the program. There was a bump that was very welcomed last year, where we got an extra 10 million from the legislature to really get a couple communities up and running on their development process, but that was not continued. So we've been kind of flat funding, and we're trying to reach more communities. So that's why we're trying to be a little more creative with how we're using our resources. So when we look in the revising, our new draft guidance document, we're really focusing on like these 3 points. One, we want to make sure that we recommit and finish off and improve the current process, which is just kind of selecting communities for SERP and air monitoring development, kind of our historical pathway. And we also want to affirm our commitment to non-discrimination, like we are required by federal and state law, right, to follow civil rights direction. So that's a part in this new blueprint that was implicit in the first, but not explicitly written. So we thought that was extremely important. And we're told it was really important by our community members. And we also want to also state CARB's commitment to equity in the way we roll out our regs and incentive programs. And then the final one there is to provide multiple pathways to get emissions reductions outside of the traditional SERP and CAMP pathways. So that's that third point. The way we've structured this draft version of our new version of our blueprint, it's in 2 parts. And part 1 is actually available for public comment now. And if any of you are interested, I can pass it on as well. So that teal part outlines part 1, which is basically a 5-year strategic plan. So looking, what's our vision of how this program is going to change over the next 5 years? What's the mission of the program, and how are we going to actually implement that vision? Part 2 in the blue is more nuts and bolts implementation. And we're kind of breaking that into 2 parts: the kind of conventional SERP and CAMP pathway, how are we going to improve that process? And then also on the right side, we get into some of about 3 main new alternatives for communities to bring resources to clean up the air in their communities through new pathways, which I'll get into in a second. Cool. And this slide kind of just breaks down those two blue goals from the one before in part 2. So the top lighter blue one is the idea. We really want to ensure that the SERPs that are out there and being developed are completed, right? And we're trying to rewrite guidance to make sure that we're getting valuable information from those SERPs, and we're helping the air districts and the community and all actually state and local partners complete all the actions in those plans. So that's kind of the top part of that figure. And the bottom is this new pathways idea, where we really want to focus on other communities. We've had over 65 communities routinely apply for the program and be nominated by air districts that we just have not been able to bring into the kind of historical SERP and CAMP pathway. So we really want to focus on ways we can bring resources to these 65 communities. And a large part of the new blueprint kind of details some ideas we have about that. So when we look at that alternative pathway, we want to focus on those 65 communities. You can see them here. So the yellow dots are current, SERP and CAMP communities, and the blue dots represent these 65 consistently nominated communities around the state. So we really want to focus our resources on engaging with community members, looking at other new pathways to bring resources. And what we see them right here. One is we wanted to look at pathways that CARB actually has some discretion over, where we have some legislative authority. So one is community air grants, which we can actually use to do a lot of work in these communities. Another is community focused enforcement. We've been really successful, or it looks like we are going to be in Del Amo down south, and also in West Oakland. Our enforcement division is actually partnering with community members to develop community focused enforcement plans. So it's something that we at CARB can do now. And we also want to really partner with other state agencies to help bring more resources when there's concerns that maybe sit a little outside air pollution, whether it's land use or water, things like that. So that's one idea. And we are also looking to expand those CAP incentives guidelines so that they can be used more creatively by communities. So that's another thing we're doing right now is revising those CAP incentive guidelines. So through the CAP incentive guidelines, our community air grant program, and through community focused enforcement, those are our 3 main, I guess you'd say, levers we're going to use to try to reach out to these 65 communities over the next 5 years. And a timeline development for the Blueprint 2.0. So we're starting at the top there, June. This is where we're at now. We're going to release a draft version of the document and allow public comment on it before we even get to the final draft. So we're adding kind of a pre-step with receiving comment. And part one, so that overall vision of Blueprint 2.0, the draft is released and ready, and we're receiving comment now. We've opened up a public comment period, and starting in July, we're going to have we're doing a lot of targeted outreach as well as workshops. So we have 3 workshops planned over July. One will be actually delivered in Spanish for monolingual Spanish speaking community members. And that will go all through July. Then in August, we'll take all that feedback and direction from our public outreach, develop the final draft, and that will also be released again for comment in August with a public docket. And then in September, that is when we were planned, late September, around the 27th or 28th. That is when our CAR board will meet to consider this new Blueprint 2.0, so our updated guidance document. And there'll also be space for public comment period at that board meeting. Cool. And I think that's all I have. If there are any questions.
Great, thank you very much, Brian. Yeah, let's start with panel questions and comments, and then we'll get to public oral comments. Panel members, any comments? Ahmad, go ahead.
Thank you, Kurt. Thank you, Brian, for this overview. Very helpful. I have 2 questions. One is with regard to the community nomination. Can you let us know a little bit about the process? How do you ensure that all communities get a fair share to be nominated, and what are the determining factors there? And the second thing was with regard to school notification program. I was wondering, what does it entail? What is the coverage of that program? Can you be a little bit more specific about that?
Sure. So the first part, the current nomination system is that CARB, we do a statewide assessment looking at communities throughout the state using a bunch of resources like the Healthy Places Index, Cal Enviro Screen, the emissions data we have to just look at the overall burden throughout the state. Also, communities and community-based organizations themselves will self-nominate for the program. So they'll notify us and their local air district, as well as the local air district will also put forward communities they feel that are in need. So through a kind of quantitative assessment of emission burden, and then as well as more qualitative, do they have community groups that have the infrastructure and they're ready to go to work with the air districts? Does the air districts have resources to implement the program? Things like that. We develop a list of recommendations for communities. And that process has been difficult, and there's a competitive nature to it that is definitely not ideal. So that's why our plan of this next 5 years is to look at those 65 communities that have been consistently nominated for the program and really focus on bringing resources to them. And that list isn't going to be static. As we get more communities interested in the program through outreach, we'll be adding to that list. And so that is the idea. We want to get away from this process of only nominating or being able to select, 2 or 3 communities a year for this official development of these SERPs and camps. And the second question was about the school flags program. I think that one specifically was happening down south. I can get you more information, but I think it detailed improving on the real-time data they were receiving for the flag program. And it's about like putting a notification, whether it's like LED boards around the school or using more traditional colored flags of a flagpole to let all students and faculty know when it's safe to be outside for physical activity and when kids may be brought in for PE. So that's the idea with those school flag programs. And there was funding before, kind of inconsistently, but one community, I don't want to misspeak, but it was one in Southern California, actually put together a community identified project to make sure that their schools all had an up and running and a more current notification system.
Thank you. It's very helpful. Just to a quick note, is there any mechanism in place to reward communities who participate in this program successfully and excel at the end of this period, whatever year is required for this program, to reward them, kind of give them some incentives?
I'm not sure. We haven't thought about anything at the end, but the hope is that when these communities come into the program, we're able to bring resources through incentives and enforcement mechanisms to help them achieve their goals. And really the Air District should be partnering as well. So, and that and that's one thing about our current incentive program. Only communities that have been selected for SERP are allowed to develop those specialized projects, the community identified projects. One of our thoughts with revising our CAP incentive guidelines is to allow more communities to take advantage of those types of projects. So we can see projects more tailored to the needs of the community. Now, initially the program, to get early benefits, we're like, hey, you have a program up and running, like heavy duty truck replacement, at the Air District, go ahead and use this money on those current programs so we can get some really early emissions reductions. And now we're kind of tilting it back to the idea like, hey, what kind of community identified projects have we seen that are effective? Let's let more communities take advantage of those. So that's, and again, I want to emphasize these are all draft concepts. So over the next, month and a half of public workshops and interact with all our stakeholders, we may see new ideas or tweaks to a lot of this, but that was definitely one place we at CARB thought we have the power to revise our incentive guidelines. So we're going to try to make them a little more open.
Thanks very much. Very helpful.
Great. Thank you, Ahmad and Brian. Joe? Joe, you're muted.
Yeah, Brian, it's a very nice program. Sounds like it's going very well. I had two quick questions. One is, are the communities getting good scientific input from toxicologists or cancer researchers as to what compounds should be gotten rid of? And if so, who gives this to them? So why don't you deal with that one first? That's an easy one.
I'd say they're getting all right advice. Just Heather Bolstad has been helping us out. No, I'm kidding. No, I'm kidding. We've been getting, OEHA is very involved with a lot of our communities. Not only Heather's team, but we also have researchers like Lily Wu. And so OEHA has been doing a lot of work with us to get that type of information in community members' hands. And we have tried to give really detailed, it's a mix. I want to keep this right. We have a lot of community members that are very well versed, right? And so that's, I guess, one of the challenges of the program that know a lot of this stuff and been following the air toxics program for a long time and would probably be great staff and management at CARB, right? And we have others that are new to it. So through work with OEHA and our research division at CARB, we try to create simple enough tools. And the thing, you may have all experienced this, we make a simple tool, but they're like, oh, look at this outline case or this kind of, we end up caveating a lot of our tools to death sometimes, but we have tried to develop toxic weighted emissions tools that are available online to give an idea of a way to prioritize toxics. We try to get really community focused and specific inventory so they can see the major sources in their area. So there is that educational component at the beginning of the program that air districts also participate in. And actually many, I think it might be Stockton and some others have actually developed technical advisory committees. So they've reached out to academics and local experts and maybe included toxicologists from air districts and emission modelers to help advise the committee through a subcommittee, a community subcommittee.
Okay, thank you. And then the second one is, do you have a list or can you refer off the top of your head to any compounds or substances that have come out and have been significantly reduced in the communities that you're proud of so far?
Well, from the criteria's perspective, we have seen some pretty appreciable PM reductions, as far as health impacts. And we've seen them on a range through those incident programs, especially if you don't count the exposure reduction ones, we see a pretty good return on investment on PM reductions. We also, and I wish I was better versed, I work mainly with Central Valley and Bay Area communities, but I know in the South, they're really looking at a lot of metals with a lot of their strategies, like the ethylene oxide, they'll be very interested in, so that's something that's come up. But I can point you to, we have a lot of tools that break down strategy by strategy, the type of emission reductions we're getting. So I can forward that on to Arash to share with the group, and you can look where we're at so far.
Okay, thank you very much.
Great. Thank you very much, Joe. Any other panel comments or questions? I had a question for you, Brian, and it's related to something you said in your last comment. And the question is, how do you assess success?
So our plan, well, this was the original plan. One of the ways we're streamlining reporting is that initially we did give guidance about how you would track progress, right? And we want to really leave it really open so communities could really track things the way they wanted to. And air districts, and they all have very different sources of concern and different geography, which worked well. But then as looking at the program as a whole, it was difficult to compare. Like you mentioned earlier, like we had different units, we had different time spans, 5-year goals, lifetime reductions. So it's very hard to take a kind of holistic approach of how the program was doing. So one of the big changes we're suggesting for this new round is that we're eliminating a lot of the reporting, but we want to report more on what's valuable. So we are suggesting strongly that every action that's taken in a SERP has its own target, for their 5-year milestone. And there's a unit of measure. So this is a measurable target so that we can report on percent progress. So the idea is that maybe we can't, add up PM 2.5 reductions for all the communities because they're measuring differently, but we can at least say, now we have at least a percent completion, right? So then we will know that, hey, you have that target, you didn't hit it 5 years. Well, now you hit that mark. Now we're going to come up with a specific plan to how we're going to finish that, right? And a lot of these are living documents. Sometimes the community, a good example is a lot of communities had school air filtration measures, and they put a lot of money to that and a lot of effort. But then with COVID relief and wildfire relief, a lot of these schools were getting new HVAC systems. So you'll see where these communities redirected that money to very popular like residential indoor air filtration or lawn and garden trade out programs. So every year in the annual report, these communities with the air districts get to adjust. They form us on like where they're at and then what changes they've made to their original plan. But our idea is that very simple. You have a target, it's measurable, where are you in that? So the idea is that by the end of the program, whether it goes a little beyond 5 years, that there'll be a rationale that the air district and community agree upon why action was not completed, or there's a plan drawn out to get that action to completion. Is the plan. So hopefully we'll be able to at least report back on like percent completed for every action in every plan. And some plans have 70, 80 actions. We want to really be able to track them at an individual level. So I just, last thing, our idea is that like if you have a plan, like you need to be able to know if you finish it, right? So if you develop an action, you should have a target and a way to track it, or maybe that action hasn't been well developed enough, to be included in the plan.
Yeah, thank you. Any thoughts about health-based measures of outcome or changes, hospital admissions, school absences?
So yeah, I think there has been, and we've seen the Bay Area take that route. I mean, wouldn't argue, but just my work, I would say there's so much information linking like PM exposure to premature mortality that is a health-based measure. If we can reduce PM, that's something we can measure, right? And that's just my personal opinion. But also something like there has been something like hospital-based admissions to me isn't a health outcome. It's like kind of a health care utilization method. And so there's a lot of things that go into whether somebody goes to the ER for asthma, and not related to asthma severity. And so with things like that, we can track, but you really got to you would need to, and if a community wants to do this, we've seen it, put money and resources into having a well-controlled study that takes into account all the variables. We saw changes in asthma ED visits when the Affordable Care Act came out, because now more people were seeing primary care physicians and treating their asthma, rather than having to go to the emergency room. So the community is very interested in health metrics, and Bay Area is actually looking at one of their goals is to reduce cancer risk. So, and that's more mathematical process, right? So they are looking at emissions and then atmospheric modeling, and exposure to then estimate the reductions in cancer risk. But there is a ton of interest in better, more granular healthcare and healthcare utilization like data for sure. And actually our research division has some research projects looking at that.
Gotcha, that's great, thank you. Any other panel comments? All right, seeing no more panel comments, we're going to open it now to public oral comments. And I'm going to rely on Arash here to tell me.
Yeah, I don't see any hand raised. We just checked it and it was working. So I don't think we have any comments. I'm just gonna put in the chat the link to.
We do now have one, yes.
Okay. Let me turn on the clock. Okay, I'm gonna set it for 3 minutes since we have the one.
Sure, that sounds good.
Mm-hmm.
And can you unmute?
Yeah.
Or allow? Yeah. And then
Linus, you can unmute now and provide your comment.
Okay, great. Thank you. I hope you can hear me. I'm Linus Farias. I am actually speaking on behalf of CEB, which is the California Council on Environmental and Economic Balance. We're a group that's worked on the AB 617 effort for many years, and involved with a lot of the industries that are associated with, in some of them in AB 617 communities. And so I appreciate this presentation. I got a couple of quick questions for Brian. One is, in the slide you have on statewide emissions reductions, you have masses in terms of tons of reduction of PM, NOx, and ROG. I wanted to find out if those numbers are total numbers over what time, and what percentage of those, does that represent the percentage reduction in these 617 communities, or is it kind of a percentage of that? Is that a gross number there? That's one of my questions.
Got it. So yeah, I should explain that slide better. So those are estimated lifetime emission reductions of the projects funded with incentive funds from 2017 to November of 2022. And if you look at that slide, I don't know if you have the PDF, I can't share my screen right now. So
yeah, I'm looking at it. Yep.
Okay, yeah, so those are lifetime emissions from those projects that are shown on the left side, where we split up the money by source. And the percentages just show that of those emissions, 30, like let's say, like if we look at tons of PM, 36% of those emissions are happening within those 18 communities that so far have been selected through our traditional pathway in the program, and 64% are happening in the air districts and in other disadvantaged communities, but not officially selected ones. So can give you an idea of where that benefit is happening throughout the air districts.
Okay, so this is filtered by the actual just disadvantaged communities. That's the numbers for those, the reductions in all communities.
Right. So that's all like, and that's by the California state definition. So you're talking like SB 535, and Cal Enviroscreen definition of a disadvantaged community, based on census tracts. And if you want to, Linus, I think that Arash put it in there. It's the annual report link, has more detailed information about the progress of the emission reductions over the last year. I think we break it out by air district in that report. So, or you can email me too. Like, I should drop my email. I don't know if I can.
Yeah, it's in the slide deck there. So that's great. I'll shoot you a message. And quick thing, in the 25 seconds here left, when do you anticipate the part 2 of the blueprint document to be released?
I'm hoping really soon. It's under EO review. Our executive office has it, and what's the 16th? Hopefully in the next week. And I've already submitted the version for Spanish translation. So we're hoping to have both of those really soon. Probably the English version in a week, and hopefully the Spanish version within 20 days.
Excellent. Thank you.
Great, thank you, Linus, for your question. I'm looking, I don't see any other questions. So any members of the public, if you have any items or any questions, please raise your hand.
I don't see any other hand raised.
Okay.
I'm just going to remind everyone that you can submit your written comments in the links that we provided earlier. I just posted them in chat. You can find it in our website and also in the chat. And the portal is open until July 1st.
Great. Thank you, Arash. All right, seeing no additional oral comments, we'll conclude that section, which brings us to our final item, consideration of administrative matters. Any thoughts from the panel? Anything that I didn't get a chance to say that you'd like to say now? No. Okay, great. Second, we do not yet have a next meeting planned, but we will be working on that hopefully soon to get that going. Third, I'd like to thank James, our intrepid court reporter, for all of his work behind the scenes. And fourth, I'd like to thank Arash for really organizing all of this and running the meeting through Zoom. I appreciate all the work that you've done.
Thank you, Corey.
And with that, I'm looking for a motion to adjourn. I see none. Oh, okay, well, we'll go for another hour then.
Everybody's waiting for another one.
Yeah. Nobody?
I move to adjourn.
All right, let's vote. All in favor? Fantastic. The motion passes. We will adjourn. Thank you very much, panelists, for all of your work. Beata, have a good night.
Thank you.
And thanks to everyone for participating today.
Thank you, everybody. Have a great summer.
Yeah, and thanks to the
Thank you.
presenters as well. All right, goodbye all.
Bye. See you. Nice to see you.
Bye, everyone.